Hello, folks. Great to see everyone trickling in. Hopefully my sound is okay and everything else seems on the up and up. Is this the, Naverio and Totally Normal Cat are conspiring to recommend? I think the puzzle that I watched Naverio spend 6 hours doing on his stream. I probably won't do that one, but we'll see. Oh, I see. Okay. I was confused by my setup there. Anyway, welcome. It's good to see lots of you. We got Jay, Corporate Commander, Tristan, Jessica, Totally Normal Cat, Nell, Naverio, Acid Helm, Admiral Malcor, David. Nice to see you, David. Thomas, Andrew Sarkis, Sayori, J40, Chili, Plebiscite. Lots of folks. Doomdiat. Hey, Doomdiat. So let's see. Do I have anything today that I should plug? I can mention that on Wednesdays we've been doing this little intro to Sudoku thing. So sort of teaching you the basics of some particular type of Sudoku. So we did Arrow Sudoku last Wednesday. So if you want to go learn some more stuff about Arrow Sudoku, that's been posted to the channel. So if you missed it, you can go back and do that. This Wednesday, I'm doing Snyder notation, so the way we mark cells in the corner and the center, and the way we use all of these tools to solve puzzles. And as part of that, I'm also going to talk about anti-night and non-consecutive a little bit. So if you have any puzzles that highlight Snyder notation, pairs, triples, anti-night, non-consecutive, that kind of genre of things, like puzzles that are about sort of tracking tuples and that kind of thing. I'd be very interested in any suggestions. They can be classics. They can involve mild constraints, nothing too crazy, but anything in there that you think would do a good job of highlighting that. I realize that sort of each of these intro streams, I've been sort of talking a little bit about Snyder notation, but I haven't really ever talked about what it's for. I haven't really ever talked about what a pair or a triple is and these sorts of things. So we're going to do that on Wednesday, and we're going to do some examples of that. So if you have any of your puzzles or other people's puzzles you think would make a good demonstration of that, let me know. Also, that's right. Also on Monday, but that is before Wednesday, if you're keeping track of the way time works, Tristan and I are going to crash into some more planets in Outer Wilds. So if you want to watch us continue to explore Outer Wilds, I will see if I remember anything about what's going on in Outer Wilds. We will see. But we will do that more on Monday. So looking forward to that as well. But today we're going to start with the most voted on question, or the most voted on puzzle of the week. So every stream, we do the puzzle that is most voted on by the supporters. So if you support on Patreon or YouTube at an appropriate level, you get voting rights. You get to see everything on my sort of up and coming bucket list, and you get to vote on whatever you think sounds most exciting. So this week, people have chosen to vote for this puzzle, and these puzzles have always been phenomenal that people have voted for, so I am looking forward to it. Oh, and David has donated for starting off part 2 with an immaculate Jay Dyer puzzle. Yes, thank you, David. Thank you so much. And yeah, I'm looking forward to the Jay Dyer puzzle. Is it because Jay Dyer has 7 letters? I'm going to guess it's $7 because Jay Dyer has 7 letters. That's my guess, based on David's previous patterns. Very exciting. And this time, and this is not particularly common, this time people have voted for me to do a 3-star puzzle, which does not show up too often, so I will take it while I can. Usually I just know any 5-star puzzle that I put in the bucket immediately gets voted as the any 5-star chaos construction that's going to take 3 hours just immediately gets voted for. But this time we get to do something maybe not as intense. Let's see. Okay, so we've got normal Sudoku rules. I'm happy so far. Within the grid, a single orthogonally connected region of flooded cells. Digits in flooded cells must all be less than n, where the value of n must be determined. And digits in any non-flooded cell orthogonally adjacent to a flooded cell must be greater than or equal to n. Digits less than n may be non-flooded if they are separated from the main flooded region. We're going to read this this rule set a bunch of times, I will tell you now. Circles are flooded and squares are non-flooded. Okay, so let's establish that flooded is blue. So flooded is going to be blue and non-flooded is going to be green. I think that sort of seems sensible to me, since water is blue and land is green. All right. So I think we're going to establish that the digit in a circle or square gives the total number of cells of the same type visible horizontally or vertically from that cell, including the cell itself. Flooded cells block the view of unflooded cells and vice versa. All circles and squares are given. Okay, so let's go over the rules again so I can understand them maybe. Okay, so we're going to color some stuff blue and some stuff green. The blue stuff's going to be small, in quotes, and the green stuff is going to be big, in quotes, where the definition of small and big is to be determined. Let's see, I want to highlight the connectivity stuff. So the blues are orthogonally connected. That is important. But the greens are not necessarily orthogonally connected. I don't think we have anything that tells us that the greens are orthogonally connected, so they are not necessarily. But the blues are orthogonally connected. Okay, and so there's some upper bound for what the biggest a blue cell can be. And so digits in a flooded cell must all be less than n. Oh, strictly less. Okay, sorry. Strictly less than n. So there's some upper bound, some overbound, we'll say. And then the digits in any non-flooded cell orthogonally adjacent to a flooded cell must be greater than or equal to n. Okay, so let's start with, I think that last part tells me that this cell has to be blue. Because we have that, I don't know what n is, but n has to be, I believe, at least 1. I think n has to be at least 2, say. And so any non-flooded cell that's adjacent to a flooded cell must be greater than or equal to n. So this cell cannot be green. So this cell is blue. I'm going to start with that. All right. So just so that we're completely clear, I want to convince myself that I actually know that n is not 0 or something silly like that. It would be weird, but what is my constraint that tells me n can't be 0? Because all of, because all of the blue cells have values less than n, right? So n can't be 0 because there are blue cells. And so going back here, blue actually has to be, n has to be at least 5 just from looking at box 6. Because if I minimized these cells, the minimum would be 2, 3, 4. And so n therefore is at least 5. So we actually know n is at least 5. And so in particular, 1 is definitely less than n. And so I stand by my statement here. Now, again, n is at least 5. So this 3 must also be blue. Oh, no. Sorry, that's not true. because here's why I don't know. Because I don't know that this cell is orthogonally adjacent to a blue cell. And we only get any restriction on green if green is orthogonally adjacent to a blue cell. So if, for example, the land looks like this, then I don't know anything about the 3. Similar thing going on with this 4 here. That is telling me that problem. Okay, so because n is at least 5, and all unflooded cells that are next to a flooded cell have value at least n, right? Let me double check and reread that sentence, but I'm pretty sure that's right. So you determine any non-flooded cell or that. Greater than or equal to n, right? N is at least 5. This one has to be at least n, and this one has to be at least n, so these are at least 5. So these are from 5, 6, 7, 8, 9. Now, this cell actually is also in a square, and so it actually can't be 9, because a square is counting the number of matching cells that it sees vertically and horizontally. And so if you look at this cell, actually, the maximum, does it count itself? Let's double check if it counts itself, including the cell itself. So the maximum this could see is 1, 2, 3, 4, 5, 6. The maximum this can be is actually 6. So we have that. Yeah, so someone was asking about how puzzles get picked. Broadly, I just pick puzzles that I think look good by browsing LMD. For the tutorial series, I've specifically been soliciting, hey, if you have any puzzles that are 1 or 2 stars that meet these criteria, then you can send them to me. Normally, I don't accept sort of direct submissions. But Derek is right that the turbines, that is the sort of the top tier of the Patreon/YouTube members, turbines can directly suggest puzzles and get those put into the bucket and all of that kind of thing. So Naverio, I think, is pointing out the thing that I was about to say, but then I got distracted answering chat. So because this is at least 5 or 6, if this cell was blue, well, this cell is broken. So this cell can't be blue, it's green. And so, in fact, actually, at a minimum, these cells are all green. Because if I made any one of these cells blue, I would make it impossible for this cell to be at least 5. Okay. So here's an interesting thing. If this cell is green, so is this cell, and indeed so are all of those cells, because of the connectivity. I'm not saying that's a problem, but I just want to see if I can make any deductions from the fact that if this cell is green, this, in fact, can't be a 5. It's automatically a 6. The only way that this can actually be a 5, in fact, is if it looks exactly like that. But I don't quite have a way of wrapping my brain around this yet. Oh, that's a good point. Okay, so Totally Normal Cat has a smart way of thinking about this, which is to think about this cell and say, okay, what if this cell is blue? Well, if this cell is blue, then this still has to be at least 5, so that cell's green, and then the puzzle's broken. So this cell is never blue. This cell's always green. I agree with that. Thank you, Totally Normal Cat. That is wise. Now, this cell already, if you look at it, it already sees at least 4 things. So what do we know about n now? We know that n is at most 6, because this cell is at least n. So n is 5 or 6. And so this cell, on the other hand, I know is at least 4, but I know is strictly less than n. So this cell can only be 4 or 5, if I understand the rules correctly. All flooded cells are strictly less than n, and n is at least 5. But this already sees 4 cells. Likewise, this cell, if I look at it, this is going to do it. Each of these is at least 3. And at most 5. Wait, no, I don't know that they're at most. Yeah, at most 5. Right. At most 5 because n is at least, n is at most 6. So the point of this is that these form a 3, 4, 5 triple, if I understand correctly, because all of these see at least that. All of these see at least that many. This one all the way obviously isn't 4, by the way. And as soon as I'm 100% convinced I believe that this is really a 3, 4, 5 triple, then it tells me that this is a 6. And then that tells me that n is in fact 6. I think I believe that. So every blue cell is at most 5, is the point. So these are 1, 2, 3, 4, 5. It's not 4, that's not 4, that's not 4. That one's not 3. This one's not 1. This one can't be blue anymore. It's green because green is 6. So 7s can't be blue. This being a 6 tells me that this is green, which tells me that, all of this is green. This currently sees 6 green cells, but 6 is not enough. So this cell has to be green. Because otherwise it would repeat the 6 in the box if this was not green. So this is 7, 8, or 9. Now, this 3 can't actually touch blue orthogonally, because if the 3 touches blue orthogonally, it breaks the rules. So these are actually both green. And as soon as those are both green, this can't be 7 anymore. It's actually now at least 8. Okay, good things are happening, I think. So pause for drink. Okay, so I think I'm slowly getting this. Okay, so this cell has to be at least 6, just because it sees a 3, 4, 5 triple. It already sees 3 things. So this is at least 6. And because this is at least 6, this cell is always green. Because if this cell were blue, this would be at most 5. So this cell is green for sure. And this is, let's see, at most, it would be 8. By the way, I appreciate what Nicholas is saying. You should like the stream if you have not. It makes the world a better place if you like the stream. Okay. One of these is 3. So that means this cell is green. Because if this cell were blue, all of these would be at least 4. So that cell is green. Yeah, this we know is 4 or 5. This one can't be 5 now. This one's at most 4. Oops. Can't be 5 now. So we have that. This is 3 or 5. If it were 5, it would look like that. This is 4 or 5, so I know one of these is green. Do I know any shores that I could pencil mark other than the ones that are already sort of implicitly done? N's not allowed to be 5 because there's a blue cell that contains a 5. And blue is not allowed to contain N ever. Yeah, circles can't be 1. You're right. Circles can't be 1 because waters are connected. Right. So it's not that blue can't contain 1, it's that circles can't contain 1. Okay. Let's see. Do I see other tuples floating around here that excite me? Not immediately, but that doesn't tell me a lot right away. Let's see, I'm trying to think if I can do any sudoku here. So, I know there's a 3 in one of these cells. That doesn't really tell me anything. This can be blue if this is a 6, unfortunately. Let's see. I'm trying to parse this statement about 2. Ah, right. 2 can't be here is the point. I see. Okay, so Chili points out this cell can never be 2 because it's not appropriate for a Shor digit. So the 2 is over here somewhere. I'm not sure that immediately tells me much, but maybe gets us somewhere. What's the minimum this cell could be? So I think the minimum that this cell can be is 5. Because if this cell orthogonally touches blue, it has to be at least 6. Otherwise, it doesn't. But if this cell doesn't orthogonally touch blue, it has to be at least 5, because it has to have all of those. So this is something like 5, 6, 7, 8, 9, for whatever that is worth. Let's see. Nicholas is looking at row 5, column 7, and thinking about what the world looks like where this is a 3. If this is a 3, makes that shore, makes this a 4, makes that water, makes this a 5. I don't immediately see what it breaks. Let's see. Okay, and n is 6. I have to keep reminding myself that n is 6. So there's at most 6 blue cells in any house. I don't know how useful that's going to be, but that's something I have to keep in mind, is that no, at most 5. There's at most 5 blue cells in any house. Yeah, I keep eyeballing the negative constraint as well, because it is said that all squares and circles are given, so we have to be a bit cautious about when that is going to come up. I was going to say it tells me that this cell isn't 5, but I already know this cell's not 5. I should go ahead and pencil mark these. Maybe that'll lend some insight. So these are from 2, 7, 8, 9. And this one can't be a 2, because rules. Yeah, having blue cells in your house is not nearly as much fun as it sounds like at first. Oh, this cell can't be 7 because there's a 7 in the row. So one of these 2 cells is 7. Admiral Malcor points this out, so this cell can't be 7. Let's see. Kerbon says row 2, column 5 can't be 2. Right. If this is 2, then that immediately makes all of these cells green, which then strands a sort of lake over here. So very good spot. That's not 2. Let's see. Are there any other cells like that? The same thing happen if this is 2? No. It gets out that way. Let's see. Do I know anything about the value of this cell? I mean, I know it can't be too small. Yeah, I guess the point is this rectangle I also know has to be pretty big, just like this one. This rectangle has to always be at least 5, because if this touches blue, it has to be at least 5, and if it doesn't touch blue, it has to be at least 5. So this is 5, 6, 7, 8, 9 as well. So 5, yeah, it can already get to sort of 6 without this cell. Let's see. I'm trying to avoid looking at sort of like all the possibilities for this triple, but it's constrained enough, it might be worth it. I don't think I can do that with just outright bifurcating. So row 4, column 4, blue. I don't... Oh, right. I know one of these 2 cells is blue, right? That's the point. One of these is a 5. Oh, no, if this one's the 5, this might not be blue. Right. There. I don't think I know that one of these 2 cells is blue immediately. Right. This can't be 5 because it definitely touches blue. Three, 5, 4 looks like that, to answer Ad 11's question. And I guess that... Oh no, blue can escape through this column. That's the way that blue can escape. Close. That's not quite what 3, 5, 4 looks like. Oh, no, 3, 5, 4... Sorry, 3, 5, 4 looks like that. Oh, which just makes it even easier for blue to get out, unfortunately, because now blue can just get out this way. Let's see. Nefarious is row 4, column 9. And row 5, column 9. Neither can be a 9. Ah, right. If either... That's genius. So if either of these is a 9, it makes this an 8, which makes this blue, and then makes the 9 correct, so it should be in a square. Because if this is blue, now whichever of these cells is a 9 sees 8 in the column and 1 in the row. That's genius, Nevario. I like that a lot. So this cell's only 2 or 8 now. So one of these two is the 9. That was a very good spot. Let's see. What else can we do? The fact that these aren't very big is interesting. Like, is it a problem if this cell is blue? No, I don't think so. No, I don't think so. Let's see. It's possible I should just give up on resisting just drawing stuff in and seeing what happens, but I really don't like to do that. In what world is this a 2? I guess it could look like that. No, that doesn't work. Yeah, what does the world where this cell is a 2 look like? Is there one? Oh, it would have to do that. I see. So a lot of chat is suggesting that I can figure out that blue can never make it out this way from box 6, that blue has to go around. Which I feel like I'm starting to believe if I suggest it. So if blue tries, if all of these cells are blue, blue still can't connect over here. Because if blue does this cell's now huge. If blue does that, this cell's now huge. And then blue has no other way to connect to these cells. So I do agree that blue can't connect through here. Blue does connect down through here. Unfortunately, I don't see what that tells me, but I believe it, but I don't see what it tells me. Which means row 9, column 5 can't be 2. If this is 2, it looks like this, with maybe something here, but it isolates this and severs it. Okay, yeah. So Dog, I completely agree with. If this cell is a 2, then the only way that works is if it comes over here and these are both green, which then separates the blue. So that doesn't work. So this can't be a 2. So this can't be a 5. Which is a 3-5 pair in the column is how I knew this couldn't be a 5. Let's see now. Why can't it go up, then right? Oh, maybe this can be 2? Let's see, if this goes up and right... Oh, maybe that does work. Never mind. I think I was again swayed by... This is why I hate drawing things in, because if I draw things in, then I convince myself of things that are not true. This is very easy in these sorts of puzzles to do this. Let's see. Eric says this is always blue. Let's see. Totally normal cat says if row 5, column 5 is blue, it makes the row 4, column 5 circle at least 6. It's the row 4, column... No, that's not the row 4, column 5. Makes the row 4, column 5... Oh, I think it's the row 4, column 5 rectangle is what's being referred to. Which splits the water in 2 parts. Okay, so let's just visualize this. If this is blue, then this can't be a 5. I don't see what I'm getting out of that. Oh, it's because of now the geometry of this. Wow, that's complicated. It's because now, just in terms of this is only 7 total cells, so this actually is a 6, is what Totally Normal Cat is saying. And now all of these have to be green, no matter how I finish the 6. Oh, that is a horrible, horrible deduction, but I'll take it. But oh boy, that's terrible. Let's see. So I didn't say it would be simple. I just said it would be simpler than the 5-star ones. So the point of this is, through a horrible chain, this can't be blue. So this is green because of what it does to this cell, funnily enough. Is that actually... No, it's not going to work once this is green, because once this is green, this has another outlet to get large. I'm not shocked to learn from the setter that was not the intended path. So now this can't be a 5, is the point. So now this is a 3, 4, and 5 in that order. So now this is green. This is blue. And this is blue. And this is green. And blue has to get out, so this is blue. This is not 5, that's not 5. This is a very cool puzzle, by the way. That's not 3. What about this one? No, I don't think I know about this one yet. This being 2... I guess this being 2 is okay. Yeah, never mind. This is now right. This is now... Chris has the good point that I should apply the rules. This is now a green next to a blue, so it can't be a 5. It's at least 6. This can't be next to blue because it's a 4. So as soon as this was green, it immediately makes that green by the rules. Okay, these are, remember, from 1, 2, 3, 4, 5. And so let's update them appropriately. These aren't 4. That one's not 1 or 5 either. This one's not 3. Because every blue cell is at most 5. We're actually close in this column to having our allotment of blue cells. We only get 1 more blue cell in this column at most. Which is interesting. This cell can't be a 2, because if this cell is a 2, it would need to be in a circle, because it does actually see 2 things. It's 3 blues in here. Quite enough. Let's see, I can ask about where 3 and 5 go in this box. So 3 in this box... Oh, no, sorry, this is not a 3-5 pair anymore. Yeah, so I guess, yeah, I can be slightly more diligent about pencil marking green cells that are next to blue cells. So these are all from 6, 7, 8, and 9. And this one's not 6 or 7 immediately, because it sees a 6 and a 7. This one's not 6. 8 or 9 is interesting. Oh, good point. Okay, so now we have a 6, 7, 8, 9 quad here. So these are from 1, 2, 3, 4, 5, and not 4. They're from 1, 2, 3, 5. Which is interesting. So this is small. Let's see. What about this row? Nope, don't see what I'm supposed to see in that row yet. Right. This conveniently is less than 6. This is less than 6, because n is 6. So that immediately expands green out over here, which is huge, because it immediately extends blue down here, because blue has to connect. And now this cell can't be 2, because blue has to connect. And so actually this cell's also blue, just so that blue connects, which means that this is a 5. So this is not a 5. Just because blue has to sort of connect around through here. Oh, I already have my 5 blues in this row. So this cell's green, because remember, you can't have more than 5 blues in a house. So this is also from 2, 3, 4. Oh, fascinating. Okay, so this 5 is vertical, so it has to be a continuous string of 5. So we can do little Renbon logic to argue that these 2 cells are always green. Because of this is a 5 contiguous. So this cell is, we'll remember this time, just recreationally, we'll remember that this is 6, 7, 8, or 9. This can't get to 5 anymore, because the most it can get is to 4. This is resolving in a super cool way. This row actually can only have 4 blue cells in it, for whatever it's worth. I guess only one of these 2 can be blue. Oh, this cell is too small to touch blue, is something Andrew's pointing out. So these are green. Because this cell is not 6 or higher. Rules and stuff. Okay, so what's the maximum this can be now? 1, 2, 3, 4, 5, 6, 7, 8. So this can't be 9 anymore. It's there aren't 9 cells it could see. Oh, oops. I screwed up the coloring. This can't be 9 anymore. There's not 9 cells it could see. Oh, you're right. I removed 5 from this cell, but I absolutely couldn't remove 5 from this cell. That is correct, dog. This still can't be next to blue, though. So these are both green. And so as soon as that's true, it's still the case. This is at most 1, 2, 3, 4, 5, 6, 7, 8. This is still at most 8. interestingly, one of these two is a 4. I can pencil mark because there's got to be a 4. Oh no, sorry, I cannot do that. Sorry. One of these 3 is a 4, but it could be... Oh no, it can't be that one. This one is also... All of these, in fact, these are a 6, 8, 9 triple. That's the point. These are all touching blue. And so they're all 6, 7, 8, 9, and so this one's not 7. And so now this cell can't be green, because if this cell is green, now it's not big enough because it touches blue, so this cell's blue. Let's see. I know one of these two is a 5, but I don't think it tells me much. Yeah, they always have to be 1, 2, 3, 4, 5 if I have 5 blue cells in a house. Do I have 5 blue cells in a house somewhere that aren't marked? Other than the ones that are implicitly marked? I can mark these for you if that's the one you're concerned about. But I think Woofers sees a house I have not noticed that has 5 blue cells. Let's see. This is also 6, 7, 8, 9 because it's a green that touches a blue. This can't be a 2 anymore. I agree with Nicholas there. It sees at least 3 things. Let's see. Yeah, if this is green, I disconnect blue, which is totally normal cat's point. But yes, if this was green, it would definitely disconnect blue. So it's not blue. Sorry, so it's not green, it's blue. Gorgeous observation. So this is, of course, 1, 2, 3, 4, 5. This... Oh, no, this could be blue, sorry. That would make this a 5. I was thinking that would make this not a 3, but I don't know if it's a 3 or not. This can't be 2 anymore, can it? Oh, maybe it could. Never mind. Let's see. Mighty Blue Shell is suggesting I look at row 5, where I have, for example, this 6 looking over here. Thank you, Mighty Blue Shell. So now I have an 8, 9 pair, which makes this a 2. Makes this not a 2. This is now not a 2 or a 3, so this is a 1. So that's not a 1. Let's see. If this 5 went... No, this 5 could go this way if this bent up like that, I think is still possible. What's not possible is that these are 4s, because there's a 4 in the row. So yeah, so one of these is a 4. This cell being green, I see some people suggesting looking at connectivity logic down here. If this cell is green, I definitely separate out my blues, which I can't do. So this cell's definitely blue. I agree. This can't be 2 anymore, because if this was 2, it would make both of these green. That would definitely separate out the greens. So this is not 2 anymore. It's a really fascinating rule set. Definitely this is a rule set that you can't really understand what's going on just by reading it. At least I cannot. Let's see. Gurian is asking about this cell and looking at what happens if this is green. If this is green, then this needs to be blue. I don't immediately see the problem with that. Right. There's a contiguous line of blue. Okay, yeah. So the argument here that Chad is making is that this 5, because there can only be 5 blue cells, tells me that the 5s are a contiguous string of blue. So if this 5 went up... No, that's not the problem. If this 5 goes down like this... I think you probably have to draw this to really see it. If this 5 goes down like this, it immediately implies those are green, and now blue is disconnected. So the point is this cell can't be blue, because if this cell is blue, it forces that. So this cell is green. And so this cell is blue by the same token. This cell now can't be 2 anymore. Bye, Nell! Right. Now this blue just has to connect straight through here, right? It has no choice, right? If this is green, it immediately disconnects blue. I have no idea how that happened. Oh, it's because of this being green. This being green created this problem. So now that's blue, and again, if this were green, it would immediately disconnect blue. So that's blue. Now this is certainly not 2 again. It is 4 or 5. This is 3 or 4. Interestingly, the world in which this is a 4... No, never mind. I have all of my blues for row 7, because there's a low digit in row 7. So because there's a low digit in row 7 that's not blue, I only get 4 blues, so this is green. Just by numbers. This box has 5 blues, so these are green. That's probably the easier observation. This column has 5 blues, so that cell is green. This column has 5 blues, so that cell is green. These are, well, actually, we know that these are a 6, 7, 8, 9. I don't even have to bother writing it in, really, but we will. Because these are 1, 2, 3, 4, 5. These aren't 3. This one's not 2, actually, because it already sees 3. Just for connectivity purposes, again, we're just by, as the green sort of expands, we're creating more opportunities to notice that if this cell were green, it would separate blue. So this cell is blue. Now this can't be a 3 anymore, so it's a 5. So this is not a 5. But it's also not a 2 or a 3, so it is a 4. And it being a 4 greens both of these cells. By connectivity, that greens this cell. One of these 2 is blue. I don't know which one. This one's not a 5 anymore, so this is a 2 or a 3. Interestingly enough. This isn't a 4 anymore. This is, of course, 6, 7, 8, 9. This cell can't be green anymore. Because if this cell is green, then blue has to connect through here, but that puts 6 blues in column 6. So this cell's not green, it's blue. It's being pointed out I can fill in the circles in column 1. Thank you, Admiral. Yeah, this just is a 3. This just is a 4 by following the rules. So those are a 1-2 pair. This is not 2 or 3, so it's a 4. This is not 4 or 5. That's a 1-2 pair in the column. That makes that a 3. Makes this not a 3. This isn't a 4 or a 5. Let's see. Yeah, this can't be green anymore. Sorry, this can't be blue anymore. If this is blue, this sees at least 4 cells. This is green. So this is 6, 7, 8, 9. Now I have all my 6, 7, 8, 9s in column 4. So if this cell is green, it needs to not be next to water. Obviously, that's not going to happen. So this is blue. So this is only 2 or 3, actually. It's probably going to be the negative constraint on this cell that disambiguates everything. This now has to be blue, because if this is green, I separate out the blue, so that's blue. So this can't be a 3 anymore. It's at least a 4. Let's see. That's not 4 anymore. These aren't 4 anymore. This is just done. It's just a 3. Which makes this a 2, which means it's done, which makes this green. Makes this 6, 7, 8, 9. Also, the fact that there were 5 blues in the box makes it green. Take your pick of which one of those you prefer. This being a 2, of course, means this isn't a 2. Which means one of these two is a 2, because this row needs a 2. So one of these two is a 2. So that's not a 2. It's a 1 or a 5. This 3 looks up here and says that's not a 3, as does the 3 in the box, for that matter. Let's see. Where does Sudoku put 4 in this box? Sudoku puts 4 in this box in one of these 2 cells, but this one is a 6, 7, 8, 9, so it's not a 4, so this is a 4. And if that's a 4, it has to look like that. It does not have any choices. That was probably also a 4 just by Sudoku, now that I look at this a little bit more closely. Let's see. This column needs a 2 in blue. And there's only one place for it, which is here. Also, there's a 3 in the row. You could take that path if you wanted to be a coward about it. This one sees a 1-2 pair, so it's not a 1. Also, there's a 1 in the box. This is now a 1, 3, or 5, just for the column. Let's see. Mehdi is suggesting I do the same thing with 4 in this column, which is to note that 4 in this column is a hidden single. It can only go there, which immediately makes this green, which actually makes this whole box green. This is a 6, 7, 8, 9 because it touches blue. That was a good spot. This is a 1 or 3. Now, Mehdi points out, where does 5 go in this column? And the 5 in this column has to go here, which makes that a 3. Makes that not a 3. So that's a 1, 5 pair now. Makes that a 3. Let's see. Do I know anything about 2 in this box? Yes, I do. This cell is a 2 just by Sudoku. So there's a 2 up here. Where is it? It can't be here because it's next to water, so the 2 is up here, so that's a 3. So that's not a 3. So this is not a 3, 4, or 5. It's only a 1 or a 2, and it's not a 1, so it is a 2, which makes that a 1. This cell is a 2 or a 5, but it must be a 2 by Sudoku. So that's a 1 and a 2, and a 1 and a 5 and a 2, and a 1 and a 5. All go in beautifully. I probably can fill in this one. This one sees 1, 2, 3, 4, 5, 6, 7. This one sees 7, so I can just fill it in. It's a 7. This is not a 7. This one sees 1, 2... Sorry, this one sees, 1, 2, 3, 4, 5, 6. This one sees 6, so it's a 6. So this is not a 6. This isn't a 6. That's not a 6. Let's see. 1 by Sudoku goes here. 1 by Sudoku goes here, and that's probably all the ones. No, it's not. There's another 1 that goes here. And therefore can't be green because it's a 1 and it would be touching blue. So that's blue and that's green. This is a very satisfying puzzle, Jay. I really enjoyed this. This isn't a 6 because there's a 6 in the box. This is the last 6, 7, 8, 9, because by the row it's a 6, 7, 8, 9, but it's the last 6, 7, 8, 9 for the box, which makes this a 4, 5 pair. This cell just can't be 1, 2, 3, 4, or 5. It sees all of them. It sees 1, 2, 3, 4 in the box and 5 in the row, so it has to be green, because blue cells are all from 1, 2, 3, 4, 5. Connectedness makes that green, and we're done our coloring. And the fact that we're done our coloring means I should be able to fill in every single square in the grid. So let's do that. 1, 2, 3, 4, 5, 6. This one's a 6. So that is not a 6. This one is a 9. It got filled in the boring way, sadly, but we live. 1, 2, 3, 4, 5, 6. This one's a 6. Okay, so now we do Sudoku to place a 6 here. These aren't 6, these aren't 7, while we're saying things that aren't things. This would be a 6, if it was in a rectangle. These are, of course, 6, 7, 8, 9. That one's not 6. This one's not 6 either, because of the row, so that one's a 6. So 6 over here goes in one of these two cells. I don't know which one yet. This is not a 6, because of the row, so this is a 6. Let's see. This isn't a 3 while we're cleaning up Sudoku. That 3 ends up here. Let's see. Admiral Malcor would really like me to finish this column, so I will, as a generous gift to Admiral Malcor, we will finish in this column. 1, 2, 3, 4, 6, 8, 9. We have a 7 to finish the column. Thank you, Admiral. So the 7 over in this box is in one of these two cells. For whatever that might be worth. The rest of this box... the 5 in this box is just placed here. It has no other optionality. Let's see. This row, let's see, is 1, 2, 3. It's got a 4, 5, 6, 7, 8, 9 is what's left. This one's not a 4. So that gives me an 8, 9 pair, which makes this a 4, which... makes this a 5 and a 4. Oh no, we forgot to have a bet cell. Well, let's have a late bet cell. Let's bet on this cell. It can be a purple bet cell. We'll see. We'll see who can bet correctly on the value of this cell. You get better odds than usual. These two cells are a 6, an 8, and a 9. For whatever that is worth. This column needs a 7, 8, 9. This box has its 1, 2, 3, 4. It needs a 5, a 6. No, it doesn't need a 6. It's got a 6. It needs a 5, 7, 8, 9. That one's not a 5. There's a 9 in the column already. That helps. So that gives me a 7, 8 pair, which makes that the 5. Makes this not a 5. This isn't a 7. So that's an 8, 9 pair, making that a 7. Making that not a 7. There's an 8, 9 pair in this column, making that a 7. Making that not a 7. The 8, 9 pair successfully resolves the long-awaited mystery of the bet cell. The bet cell was a 6. Congratulations to Kurban. This is not a 6. That's not a 6 either, so that is a 6. One of these two is the 7, so this isn't a 7, despite the fact that I have had it pencil marked for a while as being able to be a 7. It's not. These can't be 7 either, so that is a 7. So that's not a 7. So that is a 7. Okay, and so now we have almost only 8 9s left. We would have only 8 9s left if I would clear up the last 7, 8. Oh, this is not resolving the way I thought it was. Because now that's a 7. That 9 is going to give us an 8 and a 9, and 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 a 9 and an 8, and an 8 and a 9. That was awesome. I really enjoyed that. But the reason I paused was to think if I ever used the negative constraint, because I don't think I did. I know a lot of people in chat spotted applications of the negative constraint, but I admit I just wanted to not use it until I had to. That was the only reason I was not using those, because very cool puzzle. I really... Row 4, 5, column 9. Right. That's right. We did that. Oh no, poor Zach. Zach should come out and do the we finished the puzzle dance. Poor Zach indeed. 81 tuple digit dance. Yes, the puzzle complete digit dance. Alrighty. I'm gonna take a real quick break, and we're gonna come back and do a puzzle requested by a super supporter. So I will be back shortly with a new puzzle. Welcome back. As mentioned earlier in the stream, people who support at the turbine level can specifically request puzzles. This was specifically requested. So Woofers asked if I would solve Zeta's nightmare. So this is an old puzzle by me, which has been getting a lot of solves lately. So I figured it would be fun to solve it. You're more than welcome to request me solve old puzzles by me, because it will, I'm sure, be, the title will be a very apt description of what is about to happen. That is my belief, but we'll see. So this is an ambiguity puzzle, where every clue in the grid is one of two types of clues. So it's either a between line clue. Let's just pick this one. Jay, this is not a debut for me on the stream. In fact, when I started streaming, actually, I just started by going through my old puzzles because I thought it would be fun. Meme Rister, I hope your vacation is going well. Never has a puzzle retroactively turned out to be better named than this, because I remember that this puzzle was quite difficult. But yeah, if you go back and watch the very early streams, I did a lot of my own puzzles, and by and large it went badly because I'm not very good at my own puzzles. I wouldn't mind going back to that, but I also like other things. Good night, Daniel. Hope you sleep well. Let's see. So, this is a puzzle I keep meaning to submit, by the way, to CTC and never actually have, but someday I will remember to submit this to CTC. So if this is a between line, the way it works is that the two digits on the outside bound this. And so this could be, for example, they can't all be 3 for Sudoku reasons. They could be 3, 4, 6, for example, if this is a between line. That's one possibility, one universe. The other possibility is that this is a double arrow, which means that the sum of the digits on the line is equal to the sum of the digits in the circles. And so, for example, in that universe, these could be... did I make this impossible? No, these could be 1, 3, 5. Okay, if this is a double arrow. All right, and those are the two possibilities. And... as with most of my puzzles that are ambiguity puzzles, you're specifically not allowed to make a line that's both. So if you ever make a line that is simultaneously a between line and a double arrow, you have broken the puzzle. Okay. Chat has already pointed out the break-in, which is that this line is yellow. And which one is yellow? Well, you have to think about, could this be a double arrow? And so if this was a double arrow, then what would happen? Well, I need to sum these 6 digits and get the same thing as summing these 2 digits. Well, the sum of these 2 digits is at most 18, but these digits sum to at least 21. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. No, I kept going. I ran out of numbers and kept going anyway. 1 plus 2 plus 3 plus 4 plus 5 plus 6. So therefore, this is a between line. So yellows are between lines. So this is a between line, not a double arrow. Okay, it's a start. Note I'm coloring the lines and not the circles, because the circles can be both. So now the nice thing about between lines that's completely broken by double arrows is that 1s and 9s can't possibly go on a between line. And so what that means is that actually if you look down here, 1 and 9 in this column have to go down here, exactly as Corporate Commander suggests. Okay. So 2 of these, 3, at least, are not between lines. 2 of these 3 have to be double arrows. because 2 of them have a 1 or a 9 on them. And so the question, I think, is, can all 3 of these be double arrows? Is it possible that all 3 of these are purple? And the answer is no. If all 3 of these were double arrows, then this would have the same sum as this, because they have the same circle, so that would have an even sum. And these 2 circles would have the same sum as this, so that would be an even sum. So in the universe where all of these are double arrows, the sum of box 8 is even, which is a pretty big problem. We cannot make the sum of box 8 even. And so what that means is one of these, exactly one of these 3 lines, is a double arrow. Sorry, exactly one of these 3 lines is a between line. I'm sorry. My brain is not doing goodly right now. Okay. Here's another point. This is not 1. I realize I said my brain is not doing goodly in a way that sounded more serious than I intended. I just meant my brain is not talky goody right now. So this is not a 1. Because if this was a 1, what is this thing? It is true that you can put a 1 on a double arrow, but you certainly can't put a 1 on a double arrow as the only digit, because you would be saying 1 is the sum of these other 2 digits. So we have that. Okay. And what are we supposed to do with the fact that one of these things is a between line? Well, the one that's a between line is, of course, the one that doesn't have a 1 or a 9 on it, which is interesting. See, Nicholas says row 8, column 5 can't be a 9. Why can't row 8, column 5 be a 9? Is there some fancy, sophisticated reason? Okay. I think the next question is about where do the green digits go in this box? That is a good question. Where do the green digits go in this box? And so, of course, they don't go here. So the green digits go... There we go. Okay, this is nice. Old Zeta was a smart fellow, apparently. The green digits can't both go here. Because if the green digits both go here, what kind of clue is this? Well, it's a double arrow, but it's a double arrow that doesn't work. And likewise, the same thing's true down here, because if I put both greens down here, I'm saying green plus green is equal to green plus some third digit. So what we're saying is one of the greens is up here, and one of the greens is down here, which means that these 2 are both double arrow clues. So we're going to make those purple. So I think it would have made more sense to do that first, but oh well. And so this is a between line. And now that this is a between line, it's of course not a 9. And so these become a 1-9 pair. Okay. Now. So let's go back to our green circles now. And think what happens. So this is my first green circle. Let's say that one shows up here. What does that mean? Well, it means that it means that if you sort of cancel that, the other 2 cells sum to this digit. And likewise, the other 2 cells down here, the ones that aren't that cell, sum to this digit. So these digits both have to be at least 3. So let's make these 3, 4, 5, 6, 7, 8, 9. Now, there's a few consequences of that that I can see. One of them is about 1 in row 8. Yes, Camille, I am solving my own puzzle because a turbine requested it, and a turbine superpower is requesting puzzles, but actually a turbine requested it, and then several windmills voted for it. So the turbine was not alone in desiring that I do this puzzle. Where does 1 go in this row? Not in this box. There's a 1, 9 pair. Not in these cells. 1 is not at least 3. Oh, did past Zeta suggest a bet cell? I have no idea, but let's make that the bet cell. We will bet on the value of this cell. So where is 1 in this row? It's not in these cells. It's not in these cells, and it can't be here either. If these are a between line, then we just can't put a 1 on it. If these are double arrows, it can't be 1 because it would be saying 1 is the sum of 2 other digits. So 1 in this row goes over here, which also tells you that this is a double arrow because it has a 1 on it. And you can't put a 1 on a between line. Okay. Now, the other thing that's interesting about these digits is 9. Remember I said that in this row, if this circle shows up here, what that's saying is the other 2 digits sum to that circle. And if this circle is the one that shows up down here, then the other 2 digits down here sum to this circle. Now, one of these 2 lines has a 9 on it. You have to ask yourself, can that 9 possibly be one of the other digits in what I just said? And the answer is no. The other 2 digits that sum to the circle can't do that. So what's really happening here is in this horrible mess of a box, is that we have basically 2 authentic arrows. Each of these green things is an arrow plus that other digit. And so the 9 has to be not on the arrow, it has to be in the circle, and so one of these 2 cells is a 9. Otherwise, if neither of these is a 9, one of them has to be at least a 10, which is going to be a huge problem. Okay. So Corporate Commander is suggesting looking at 2, 8 in this column, which is a very wise idea because this can't be 2 or 8. So I need a 2 and an 8 on here. Why can't this be 2 or 8? Because, and to answer your question, Corporate Commander politely asked, was this intended? I have no earthly idea. This puzzle might be a year old at this point. It's certainly long enough ago that I don't remember any of this in any more than the faint way. But 2, 8 in this column can't go here, so they both go on this line. And the reason why that's nice is because it means these endpoints have to be 1, 9, because of the existence of a 2 and an 8 over on this line. In order to bound them, in order to bound the 2 and 8, I need a 1 and a 9. So these are a 1, 9 pair. In order to make that work. Okay. So I guess we can figure out the sum of these 3 digits. No, not quite, I guess. Maybe not. Maybe I can. Probably I can do some arithmetic, can't I? Arithmetic sounds like a good thing. These can't both be double arrows. Okay, so here's another point that I don't know how relevant it is. The fact that one of these is 9 tells me that one of these has to be a between line and not a double arrow, because you can't have a 9 in a 1-cell circle there. Ah, right. Good point. Good point from Odd Garrett there. What if this was a 9? Well, then what is this double arrow summing to? Well, the maximum this double arrow can sum to is 10. But if this is a 9, I can't put a 9 on it. So the maximum that sums to is 9 now. And so then this has to be at most a -1. And since that does not work, this actually can't be the 9. This is the 9. And we have a digit. We have a digit. We have a 9. And so we can bring in Zach to do the world famous 9 dance. Thank you, Zach. Much appreciated. All right. That means that this cell now has to be a between line. It can't be a double arrow, or this would need to be a double-digit number. This also has to be a between line, because otherwise this would be a double-digit number. Hi, and bye, codec. Let's see. Yeah, so I think Kuraban is correct. I think that means this circle can't be an 8, because now if you look at this, the maximum sum of this, if this is an 8, is now 8. That's not going to work. Now, let's imagine the world where this is a 3 for a second. Then that means one of these sides has a 3 on it. The 3 has to go with a 1 and an 8 on one side. Oh, no. No, 1 second. No, sorry. Let's see. If this were a 7, this could be a 1 and an 8 with a 2. That would be acceptable. Right. If this is a 3, that's a good point. If this is a 3, one of these has a 9 on it, and then the 9 would have to go with a 1 and a 2, but 1 and 9 don't go on the same line. 1 and 9 go on opposite lines. Likewise, if this is a 4, one of these has a 9 on it, the other two sum to 4, and then you've put the 1 and the 9 together again, so this can't be a 4. So this is a 5, 6, or a 7. They can't, the triangle in box 7, they can't both be double arrows. One of them could be a double arrow. So it could be a double arrow and a between line is possible. But they can't both be. They can't both be double arrows because they would be the same digit, exactly as Add 11 says. And that shows up a few places, like that also shows up here. One of these, at least, is a between line. Let's see. So, this being a very middling digit is making it a little harder for this to be a between line, but this side to be a between line, but not strictly impossible, I don't think. Yeah, that's a good point. I know that this is a double arrow, and so the maximum sum here is 9, and so because the minimum of this is a 5, the maximum that this can be is a 4. So that's a 2, 3, 4. That is a great spot from Admiral Malcor. Okay. If this is a 2 and a 7, I guess that leaves me plenty to still make this a between line or a double arrow, unfortunately. This is pretty interesting. I guess I know there's 2 low digits in the box, sort of sucked up between these 2 places, because I know the sum here is at most 9. And the sum is, I suppose, at least 7. So I could fill in, like, this is 1, 6, 7, 8, I believe. Let's see. Kurban asks where 9 goes in box 9. Which is a very good question. Because 9 can never go on this thing. If this thing's a between line, of course 9 can't go on it. If this thing is a double arrow, well, its sum is at most 11. No, sorry, its sum is at most 9. We actually know its sum is at most 9. So I certainly can't put a 9 on it. So actually, Kuraban's point is that the 9 is always down here, which sorts out the 1 and the 9 over in this box pretty awesomely. Very good spot. So this 5, 6, 7 goes down here. Yeah, we get 1 in one of these 2 cells while we're at it, because 1 can't go on a between line, and we know this is a between line. Let's see, I'm trying to understand Woofer's point. 8 needs to be next to 1 in box 8 to sum to 9. The other circle. Right. Right. This is this circle. That's right. This row is this circle plus 2 things that sum to 9. So in particular, there's an 8 here. And these are from 5, 6, 7, 8. And then up here, if this was a 5, we would have 2 and 3 up here. If this was a 6, we'd have 2 and 4 up here. If this was a 7, we'd have maybe 2 and 5 or 3 and 4 up here. So I guess we know these are always from 2, 3, 4, 5. It's actually getting a little bit interesting with the row. But these need to sum to at most 7. And so they have to come from this assortment of stuffs. Oh, wait, this can't be a 2. I think this can't be. If this is a 7, I think this can't be 2, 5. Because if this is a 7, this digit's a 2. Yes, Tall Cat, yes. A Turbine requested a solve of this puzzle. So the title is very apt at the moment. This was just like seeded a year in advance to torture myself. Good point. Okay. J40 has an absolutely awesome spot, which is where does 8 go in box 9? 8 can't go on this. 8 would never go on it if it's a between line, and if it's a double arrow, it sums to at most 9. And so it can't have an 8 and 2 other digits on it. So 8 in box 9 actually does go here. Gorgeous spot. So this is actually a 1-8 pair. So that's awesome. So now we know 8 is up here somewhere. I don't think I can rule 8 out of any of these immediately. If this is an 8, then these are both between lines, but of course it seems very plausible that they're both between lines. Oh, here's a good question. Where does 2 go in this row? Oh, no, maybe 2 could go in one of these cells. Never mind. 2 could go in one of these cells. 2 can't go here, but I don't think there's a reason why 2 can't go here. 5 isn't on the double arrow in box 8. I was saying this side couldn't be 2, 5. So if this is a 7, it's a 7, 3, 4. Right. Okay. So these sets of 3 cells have no digits in common. You might think, oh, could they both have a 5? But they can't both have a 5, because if they both have a 5, then this is a 5, and so the sum of this double arrow is 14, but then it has a 5 and a 9 and another digit on it. So the fact that these two have no digits in common means we're roped. And so what that means is that these digits in this box, these 3 digits, they go down here. So these are from 2, 3, 4, 5, 9. I'll think about what I can do with that in a second. It means that these are from 1, 8, 5, 6, 7. These are from 2, 3, 4, 5. Because of that. And let's see. This is the weird middle one that we don't know much about, and then this is the weird middle one that we don't know much about. Right. Okay. So this cell is never a 2, because if there's a 2, there's no way to make it work. If this is a 9, oh, interesting. This can't be a 9 anymore, ever. Because if this was a 9, what on earth is this? There's nothing that would be between these 2 digits. So this is never a 9. Let's see. Likewise, this can't be a 5. Because if this was a 5, there's nothing I could put on either a between line or a double arrow to make this work. So this isn't the 5 either. So this is 2, 3, 4. That's a second 2, 3, 4 for the box. Let's see. If this is a 9, these have to sum to 9. Which would mean, if this is a 9, these have to sum to 9, which means this can't be a double arrow. It has to be a between line. But I don't quite see yet how to make this work. I don't know that this is a double arrow yet, Doug. Oh, wait, no, sorry, you're right. No, sorry. These two even outright would have to do it. Yeah, the purple way, right. These sum to 9. So yeah, this definitely isn't a 9, because if this was a 9, right, these two digits already sum to 9, so it's not possible that these two digits sum to 9. Very nice. Okay, well spotted. So that's a 9. So we know where the 9 is now. At least a little bit. Do we want to ask about 7 in row 7? This digit's never a 1, for sure. I guess I already had that sort of pencil marked over here. 7 in row 7 is either here, or over here. Yeah, so the question is, what happens if one of these is 7? Yeah, right. If one of these is 7, then what kind of line is this? It's definitely not a between line. But if one of these is a 7, it can't be a double arrow either, because it would need to sum to 9, which would have to be 7, 1, and 1, except the one that's in this box can't be. Gorgeous. So, correct. There is a 7 over here. Well spotted to Admiral Malcor there. So there is a 7 over here. So it joins the 1 and the 8. So there is no 5 or 6. And because roped, this is a 7. It can't be... Why can't this be 6 plus 4? Because the sum of it is already locked in to be 9, because it's 1 plus 8. So that's a 2. In fact, not even max sum. The sum literally is 9, because we have that 1, 8 there. So no 2 up here, but these two need to sum to 7, so no 5 either. So this is a 3, 4. We know there's a 7 down here, and so it must go with a 6 as well. No 5 or 8. This must be a 6-7 pair, because I need to make these things sum to 13, right? No, 15. No, I did that wrong. Rewind. What's the sum down here? I need a 7, and a 1 is 8. No, it's just 7. I already knew there's an 8 down there. The 8 is with a 7. Don't listen to me. 7 plus 8 plus 1 is 16. That's the whole thing we learned from over here. And so now we know what these digits are. These digits are now a 2, a 3, no, not a 3, 2, a 5, and a 6. And so this digit now has to be a 5, living between a 2 and a 6. These aren't 5. These are from 2, 3, 4. So these digits are a 5 and a 6, meaning that this is definitely these are definitely a between line, because 5 plus 6 is not going to equal 9 unless I include a -2. Good point that there's a pair in the row. So this digit is between 2 and 7, so let's just fill it in. It's 3, 4, 5, or 6. Those are the options. This has to be a between line now as well, because there's just no combination here that makes this a double arrow. This is not a 2, because there's a 2 in the box. In fact, I know that this is a 3, 4 pair. Actually, because of the roping. This is a 3, 4 pair. And so the question is, if this is a 3, 4 pair, what way does it go? And the answer has to be 3 and 4, because as established, it is it's a between line. So this is not a 4. These digits over here are, this is the 2, 5, 6 extravaganza. So this certainly can't be a 6. It's a 2 or a 5. This can't be a 2 either, because this has got to be on the between line. So 2 would not be on a between line between 5 and 6. I'm squinting at these and seeing if there's a chance that this is... I'm squinting at this and seeing if there's a chance that either of these is a double arrow, and the answer is no. The sum can't be 4 straight up, because I can't include a 2 or a 5 in a sum to 4. The sum also can't be 3, because although you could think, oh, I'll put a 2 and a 1 here and that'll make 3, that would be a fine double arrow, but then the other thing is now a between line with its ends as 1 and 2. So both of these are between lines, is the upshot of all of that. So these are also between lines. This is a between line, so this number is at most 7. Thanks, past Zeta, for that lovely present. Now, it looks like there's 2 different ways that this could resolve. This could be a 5 and a 1, or it could be a 2 with a 7 or an 8. It seems like all of that is feasible. To me, at least, it seems feasible. Let's see. I'm probably supposed to start peeking at what on earth is going on in this box. Some nature of insanity is going on in this box. Let's see, I do need to put a 9 over here somewhere. That's not very interesting. Oh, here's a good question. I have to put a 9 in column 1 somewhere. Where am I putting the 9 in column 1? 9 on this line looks a little sketchy already. It's just barely possible. Obnoxiously. It is just barely possible. Because if I put a 9 on this line, it's a double arrow. And so now the sum of this line is at least 15. But then I could make these things from, say, both from 7, 8, 9, and maybe I can make it work. Just maybe. Oh, 1, 2, 3, 9 breaks this box? Right. There is a 1 or a 2 in these cells. That's the point. I don't know which, but there is a 1 or a 2 in there. And so the actual, if there's a 9 on this line, the minimum sum would be 9 plus 1 plus 3 plus 4. Which would be 17. Which would mean that I would need a 9 on this line and an 8-9 pair here. Oh, 1, 3, 4, also not possible. Good point, because there's a 3, 4 here. So, actually, the minimum is more than 9 plus 1 plus 3 plus 4, which is too many. It is, so the minimum would be 9 plus 1 plus 3 plus 4, but that breaks, so I need to go at least 1 more than that. And now I'm at 18, and I can't get to 18. So the 9 can't go up here. The 9 has to go down here. And so once there's a 9 there, that means that this is a double arrow. If this is a 1... Oh, if this is a 1, this no longer works. Actually, this is the same argument that happened over here. If this is a 1, now this is a double arrow with a 9 on it. But now, because this is a 1, the maximum this can sum to is 9, but there's already a 9 on it. So that does not work. So this is not a 1. So this is a 1. Once this is a 1, this is not a 2, it's a 5. That's a 6. That's a 2. I can get rid of the corner marked 8. Okay, good. So there's not a 1 on this line. So this line is now very eligible to be a between line. Okay, so yeah, let's ask about 8 in column 1. Did you do this on your stream ranks? I don't remember if this was like if this is so old that if this was back before you requested that people not submit impossible puzzles. So yeah, what if 8 is on this line now? The minimum sum would be 8 plus 2 plus 3 plus 4? No. 8 plus 2 plus 3 plus 5. This would have been the title. 8 plus 2 plus 3 plus 5 is what? 8 plus 2 plus 3 plus 18. Yeah. 8 can't be on the line either. So the 8 has to live here? Isn't that not possible? No. 8... I did it badly. Because 8 definitely can't be here. Because if 8 is on here, then this needs to be an 8-9 pair, and it can't be, because this can't be 8 or 9. So 8 definitely lives on this line. So I did my math badly. Right. If this is a double arrow with an 8 on it, what happens? If this is a double arrow with an 8 on it, then the minimum is 8 plus 2 plus 3 plus 5, which is 19, which is too many. So this is in fact a between line with an 8 on it, which means that one of these circles has to be a 9, and it can't be that one because there's already a 9 in the box. So that's a 9, which resolves our 1 and 9 from our intro to the puzzle. And that 9 actually places this 9 there. And now I've got a 9 in one of these cells I'm going to go ahead and mark. Okay, so this cell now has a maximum on it, because I could put 8764 on here. That's the best. 8764 is the largest numbers I can put on here. So this number is at most a 3. Now 1 is just not possible, and 2 is not possible. So this number is a 3. 1 and 2 are not possible. Wait. Yeah, 1 and 2 are not possible because of this line sum. This line sum is at least 11, and I can't make at least 11 with 1 or 2. So this is a 3. And now this has to be an 8 in order to get to 11, with that being a 2. That's the only way to make this work. Now where does 3 go in column 1? 3 in column 1 goes here, because 3 can't go on a between line with 3. Alternatively, the 3 looks down and makes that a 4. That's a 7. Okay, so now, I guess now this between line is just worthless, because now we can just fill in. It's 4, 6, 7, 8. Woo! It doesn't really do anything. 7 in this box. No, 7 in this box could go here. Don't listen to me. Let's see. I do believe the negative constraint will be useful somewhere. I don't think I would have included it recreationally. So interestingly, what can this digit be? It cannot be 1, because... Oh wait, no, it could be 1. No, it can't be 1, because one of these would have to be a between line, but it can't be because there's a 2 there. So it can't be 1, 2, or 3. So this has to be at least a 4. Well, this can't be a 4 because there would be nothing to put on the one of these that's a between line. So this is actually now at least a 5, and it can't be bigger than 6. So this digit can only be a 5 or a 6. Which is very interesting. So if this is a 3, 5, then this would be a 4, 8. Oh, that doesn't work. Ha! If this is a 3, 5, then what's going on with this pair of cells? Well, one of them would be a between line, and one of them, because this is a between line, Tristan, that's why it can't be 8. And I can't have an 8 and a 9 as a between line bounding a 7. Uh-oh, something is wrong? Is it? Assuming nothing is wrong, this can't be a 5. Because this would need to be 4 if it was a between line, or 8 if it was the sum, and it can't be 4 or 8. So this can't be 5, so this is a 6. And now these have to both be between lines. Because their sum is 9, and 9's already in the box. So this is a 4-5 pair. And I know the order even. This isn't a 4. One of these is a 4. Let's fill in this column, actually. That seems like a good idea. We've got a 1 left. We got a 2. We need a 3. We've got a 4. We need a 5. We've got a 6, 7, and we need an 8. This one's not a 3. This one's not a 1. Oh, this can't be a between line. That's cute. This can't be a between line because the only things that can go on a between line between 3 and 6 are 5 and 4, and this cell can't be either of them. So this is a double arrow. I sometimes think I enjoy solving my own puzzles too much. So this can't be a 5 because if this was... Oh, this can't be a 5 because there's a 5 in the box. Let's make it easy. So these need to sum to 9, and one of them is a 1 or an 8. So the other's also a 1 or an 8. This is not a 6. Let's fill in this column now. We've got almost everything done. We need a 1, a 2. We've got a 3, 4, 5, 6, and we need a 7, and we've got an 8. So this is not a 2. So we've got our sort of like 1, 7, 8 mahogany going on. So the bet cell is a 1, 2, or 7. This isn't a 6 anymore. I guess that doesn't really tell me anything, but it's good to know. Question mark, question mark, question mark. This cell can't be an 8 or a 1. Yeah, so one of these two is an 8. Where is 1 in column 4? Not there. Not there. So 1 in column 4 is either on this line or it's here. But 1 unfortunately could be here, couldn't it? I think 1 could still... No, 1 can't be. Sorry. No. Box 2 has a 1. Good point. Okay. So where does 1 go in this column? First of all, not in the box with a 1. Not in a cell that's looking at a 1-8 pair. Not in a cell with a 9. It can't join any of those cells, so this is the 1. Excellent spot. So that's a 1 and an 8. And that makes that a 7 and a 1. These are now a 2-7 pair. These aren't 7. They're 4, 6, and 8. So these aren't 8, is the upshot of that. These are from 1, 3, 5. So 1, 3 is not possible. If this was 1, 3, the only way that this would work is if it was a between line with 2 2s, or a double arrow with a 1, 3 with a 1 up here. Neither of those is going to work. So this arrow, so these circles need a 5, which means that that's a 3, which means that these circles are a 1 and a 5. So here's where we get to use our negative constraint, because these are either a 2, 4 summing to 6, but they can't be. So these cannot be a 2, 4 summing to 6, because then this would be both a double arrow and a between line. So these are from 2, 3, 4, and definitely include a 3. So that 3 looks down here and gives me the 4 and the 3. The 4 looks back up, makes this a 2 and a 3, so it is a between line. So, what about this line now? Well, if this is a 5, oh, this just can't be a 5. Oh, it keeps looking. That's a 6 and a 2 because of the 2-3 pair. If this is a 5, this line is broken. Because if this is a 5, well, there's a 3 on it, so it's a double arrow, which means that I need this to be an 11 in order to make the sum 14. So this is a 1 and a 5 in that order. So this can't be a double arrow either. Because if this was a double arrow, that would be a 7, and it would also be a between line. So this is a between line and not a double arrow. And now I ask where 7 goes in this column, and it can't go here, because 7 going here would double that. 7 can't go here, so 7 only goes here. Now I can ask where 8 goes in the column. 8 in the column only goes here. And so now we've got 1, 2, 3, 4. We need a 5, so this is a 5. Cool. One of these two cells has to be a 9, just by Sudoku. 9 can't go on its own between line. 8 has to go in one of these two cells. 5 has to go in one of these cells. Not that one. Oh, yes, I could ask where 8 goes in box 8. No? Oh, there's already a 5 in the column. That's a good point. So that's even better, actually. Because there's already a 5 in the column, the 5 actually comes over here, and this becomes a 5, 9. I'm going to look at that in just a second after I replace the 8. Oh, and this can't be a 5, so that's a 9 and a 5. Yeah, this would have been a great use for coloring the lines, because I could have just gone over this with, I could have just made the line... Oh, I guess that's terrible. I could have made the line yellow. That's awesome. That's a great spot rank, so that would have been a cool idea. I will remember that for the next double arrow between line ambiguity puzzle. But point taken. I think it's a good idea. Yeah, more roping. So these digits are known. These are 1, 2, 3... 4, 5, 6, 7, 8, 9. I was going to point out that this could never be a 5 because it would break whatever this was, but the point got kind of ruined by things. 4 plus 6 plus 7 is 18. No, is 17. So if this is a double arrow, then this is an 8. Otherwise, this is a between line, in which case this needs to be a 3. So this cell is always 3 or 8, even though I still don't know which one it is. Oh, motivation maxed out. What do you... I'd love to hear any suggestions for the tutorial videos. I think I have roughly planned out the next one, but I'm very... How did I do this again? I did this very badly. Let's try again. 4, 6, 7. Let's hit the right keys this time. I think I have the one for Wednesday planned out, but I certainly am very open about what to do for the one after that. Motivation maxed out. So this is not a 4. This is not a 6. This is not a 7. These are 2, 3, 8. This one's not a 2. This one's not an 8. Gives me the weirdest 3-8 pair. So that 3-8 pair makes that a 5. Makes this fillable. No, it makes it a 4 or a 7. So this is a 4 or 7. Hey, took a shower today. Row 4, column 5 is not 3 either. Oh, gorgeous. Okay, this is not 3 either, so that's a 2. So that gives me a 3-8 pair here. I can fill in this row. That'll probably be insightful. I need a 1. I've got a 2 and a 3. I need a 4. I've got a 5. I need a 6. I've got a 7, 8, and I need a 9. This one's not 9 or in the corner. This one's not a 4. Sorry, it's not a 4 in the center is what I actually meant to do. I think I've grown more fond of the Sudoku part of Sudoku over time, but I'm not sure I've gotten better at the Sudoku part of Sudoku over time. One of these two cells is a 5, just by Sudoku, speaking of. Speak of the devil. Yeah. Is 1 in box 3 interesting? 1 in box 3 has to go in one of these two circles. Because 1 can never go on a line of any sort. Never go on a 1-cell line of these of any sort. This is never a 1 for exactly the same reason I literally just said. So, in fact, that gives us an X-wing-ish on 1s. So the 1 in this row is in one of these two cells. The 1 in this row is in one of these two cells. So therefore, this can't be a 1. Or I'd have to put both of those 1s there. So this is an 8 and a 1. I was somehow optimistic that that was going to do more. Okay, so 3 and 8 in this box are both pushed into this sort of conglomeration of things. Let's see. I feel like this solve is actually going fairly well, all things considered. I'm going to fill in this column just so that I can Sudoku it up, because it's got lots of stuff on lines. 4, 5, 6, 7, 8, 9. This can't be a 9. This is a 6 or a 9. This can't be 3 or 8. Or 9. This is a 6 or a 7. So the thing I was looking at is one of these circles is a 5, and then this is making it to be 6 or 7. So it's either a 5 with a 7, making this a 6, or it's a 5 with a 2, making this a 7. But I think the point is one of these is always a 7. Because what if none of them are 7? Then I've got to have a 5 with a 6, but that's either going to be a 1 or an 8 or a 9 if I'm not using a 7. So one of these is always a 7, so that means that's not a 7. It's a 4-6 pair. And one of these is a 7, so these aren't 7. Oh, this can't be 5, 7. 5, 7 would make both of these 6. If this is 5, 7, also there's a 4-6 pair, which makes that a 7. But the point stands. If this was a 5-7 pair with a 6 in the middle, this would also be a 6. That does not work. But the 4-6 pair probably makes my life easier. So this is a 2 and a 5 with a 7, so this is a double arrow. So this has to be a between line. And the only digit that is between 2 and 5 that this can be is apparently a 3, making that a 2 and a 3. that means I did not do a great job with the bet cell. The bet cell is a 7. Congratulations if you bet 7. So that's not a 7, and that is a 7. This isn't a 3. That's not a 3 either. That's not a 7 either. It's a 6 or an 8. Excellent. So let's write out our options for these cells. So we've got a 1, 2, 3 in the row. We need a 4. We've got a 5. We need a 6. We've got a 7. We need an 8. And we need a 9. In particular, one of these cells has to be a 9, which means this could never be an arrow. So this is always a between line. Because one of them's a 9, and so this would be a double-digit number. So in particular, this is never a 9. Also, there's a 9 looking at it. The 9 can't go with an 8 over there. That would certainly not work. So now that means I know where the 8 in the row goes. So that's not an 8. This 9 is being pointed at looks up, so that's the 9. This is not a 9. It's a 4 or a 6. That 9 looks down at this, which seems to place a 9 here, making this a double arrow clue. Now, one of these is a 1, and it's with a double arrow for a 9, so this is a 1-8 pair, making this a 6, and that a 4. I know the order of the 1-8 because of that 8. That 8 makes that a 3, funnily enough. As you know, Sudoku is as Sudoku does, or whatever the Forrest Gump saying is. Which makes that a 1, beautifully. So now this is... So now this is a double arrow for sure, because it has a 1 on it. And so now the sum of this needs to be 11. So these two need to sum to 10. And so if this was a 6, this would need to be a 4, but it can't be. So this is an 8 and a 2, which gives me the 5 and the 2. That 8 gives me the 3 and the 8 over there. Let's see. This is a 6 or a 7 for the row. So that must mean this 5 has told me that that's a 6 and that's a 5. And then I've got... Oh, no, I don't have deadly patterns to sort out. I have a 6 over here, which is giving me a 4 and a 6 and a 4 and a 6. Yeah, so to address the killer cage thing, I do want to talk about killer. I'm slightly thinking about how to talk about it, because now the Sudoku solver tells you all the combinations that are valid. And so I think anyone who's solving puzzles is now going to have access to a thing that tells you all the possibilities just for free. And so I could talk about like how you would do a killer puzzle without that tool, but it feels a bit odd. If this is a 4, there's nothing this can be that works, because there's only be 2 and 3 between, both of which are gone. And if this were a 4 and it was a double arrow, these would have to be a 2 and a 3, but they can be neither. So this is a 7. So hopefully that's going to sort this all out. 4, 6, 7. This, by the way, at some point became a between line while I was not looking. Notably, 17 is not the same as 12. And so this is a 6. Sorry, this is a 6 and a 4, making this a between line. And we have finished the puzzle. This was a lot of fun. I enjoyed this. If other people want to suggest other past puzzles of mine, and so at some point I can sort of mix this back in. It is interesting looking back at the things old Zeta did. I do feel that this is actually a very difficult puzzle for me. Like in terms of the amount of stuff you have to spot to solve this is quite large. Which is Somehow this puzzle has been having a resurgence lately because it's been getting a ton of solves, even though it's very old in Sudoku terms. So a lot of people have been telling me about how difficult this puzzle is, and yeah, this puzzle is quite difficult. But I'm still proud of it. I am happy with it. Yeah. And don't worry, woofers. I'm still setting more puzzles. I just published vignettes. If you've not done vignettes, so I have a recently published. I have a recently published set of 6 connected 6x6s, which is much easier than this puzzle. So we'll do that. Yeah, so motivation maxed out. Part of my theory was maybe I'll talk about Little Killer and Killer together, because the logic that you use to decide how you would do Killer Cage combinations also applies to Little Killer puzzles by thinking about sort of mins and maxes and juggling around and those sort of things. And so it would be, so if I combined those, it would give me an excuse to talk about it together, but it might make the theme a bit more abstract. Or maybe what I do is I talk about Killer Cages with the Killer Cage calculator one day, and then I talk about min-max type puzzles a different day, and then go back and talk about Killer Cages and all the other times you min and max things. Yeah, box 8 was sort of a monstrosity in a lot of ways. But box 8 is actually evocative of my first ambiguity puzzle, where there was a very similar sort of system. So I have put this arrangement of things into a number of ambiguity puzzles. Alrighty, I guess I should take a short break and then come back and solve another puzzle. So hopefully you enjoyed that and didn't find it too self-indulgent, but again, someone asked me, so I won't feel too bad about it. But I'll come back with a puzzle that is not by me. I bet I can find one. All right, talk to you soon. See you very shortly. Alrighty, welcome back. We are back with Disco Demolition Night. I'm not sure what the combination disco and demolition is, but whatever. We're going to do Disco Demolition Night by Twototenth. It's pretty easy. If Twototenth makes a puzzle, I'm going to do it. Funnily enough, this is sort of a killer puzzle, actually. The only rules here are that the cells on a diamond sum to the number in the diamond. Basically, this is sort of like overlapping killer cages, if you like. We don't have to worry about repeats, because the only places where you have these four things are all in one box. Okay. So I'm going to start with thinking about gratuitously pencil marking this arrangement, because it also shows up over here. And I'm seeing that this has to be 1, 2, 3, 4, 5, 6 by the fact that it's on a 7. But if you look at this, actually, it can't be 1, 2, or 3 for the reason that 1, 2, or 3 would need a double-digit number to make 13. So this is 4, 5, or 6, which means that this is 9, 8, or 7. This is 4, 5, or 6, which means that this is 1, 2, or 3. Means that this is also 7, 8, or 9. Did I do that right? Yeah, so what's the sum of these two digits? That's the good question. So the sum of all the digits in yellow is 23. So the sum of these two digits is 23 minus 7, which is 16. And so the question is, how am I making 16 out of these? And it's either double 8, or it's the one that's not double 8. So it's the one that's not double 8. So that means that this one isn't a 2, and this one's not a 5. So I get that arrangement. And now over here, we're going to have a 7, 9 with a 4, 6 and a 1, 3. And so we're going to have sort of filled in this entire hoodigi, if you will. So now we need to look at how we're making 12 without a 7, 9. So 12 is either 6, 6, or 5, 7, or 4, 8, or 3, 9. Well, 4, 8 is the only option that works, and amusingly, it's the only option that works over here, too. So this is 2 or 6, and this is 2 or 6. Interestingly, now my 8 can't be 2, 6, and it can't be 8, 0. Oh, we should have a bet cell. Thank you, Kurabon. Do you have a good bet cell, Eric? If you have a good bet cell, I will trust your judgment of bet cell better than my own after my previous failings this episode of not picking the best bet cells. I'm inclined to pick this one, but if the setter chimes in, probably something in box 9. Do you have a preferred color of the bet cell? Let's see. That's something in box 9. I feel like the bet cell color is going to be like the next big thing in Sudoku. That is my my belief. Okay. I was just noticing that this can't be 2, 6 anymore because of the 2, 6 in the row. So this is either 1, 7 or 3, 5. I don't really see a lot to do with that just yet, but I also wanted to look down here at this cell, which can only be, well, it can't be 7, 8, or 9, or 4. So it could be 1, 2, 3, can't be 4, could be 5, or 6, can't be 7, 8, or 9. But then, and over here we've got 8, 7, 6, 4, 7, 6, 4, 3. And now I guess I'm supposed to ask myself if any of these combinations break what's going on up here. Like, for example, if this is a 3, it actually breaks. Because if this is a 3, then this is a 1 and a 6, which would then make this unable to be 6. So it can't be 3, 6 in that order. What if it was 3, 6 in this order? If this is a 3, it's a 1 and a 6, and that's a 6, that's okay. Probably there's lower hanging fruit. Okay, so this 12 here can't be 4, 8. So if the 12 can't be 4, 8, it's either 5, 7, or it is 3, 9. And so Garian's point, I think it was Garian, is that I can't pick this to be 3, 5, because if I pick this to be 3, 5, then now this has no fill. So this actually is 1, 7. That was a very good spot, by the way. That's 3, 9. 1, 7, 3, 9, yep. This 12 is in a similar position, where this 12 now has to be either 3, 9 or 5, 7. And that's not a 7, so that's not a 5 for sure. I'd like to get this to turn into a 7, 9 pair someday, but let's see. Row 3, column 5 is a naked single. That's awesome. It's not 1, 2, 3, 4, 6, 7, 8, or 9. Yep, it's a 5. Gorgeous. And we have our digitents. Woohoo! Whoop, doop, doo, doo, doop. 5 dance. Doo, doop, doo, doop, doo, doop, doo, doop. I feel like the camera's a bit too zoomed in for Zach today. Doo, doop. You've gotten a lot of very close-up penguin dancing. Doop, 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 doop. Boo, boop, boop, boop. Wada, bada, bada, ba. Thank you, Zach. We appreciate you. Okay. So there must be other clues that I should look at. This 11 looks completely uninspired. 9 in box 8. He does practice endlessly when I'm not streaming. You should see him. He's up here all the time. Let's see, where is 9 in box 8 has been called? That is an excellent question. Because there's a 7-9 pair here, there's a 3-9 pair here. I can't put a 9 with a 0. So in fact, excellent spot. This is a 2-9. So that's not a 9. So that's not a 3. And there, Garian got me my 7-9 pair I asked for. Thank you, Garian. Alrighty. Now, I just sort of recreationally wanted the 7-9 pair. I don't have any idea what I'm going to do with it, but I'm sure I'll think of something at some point to maybe do with the 7-9 pair. Let's see. This is not a 4-5. I can tell you that much. I could do the same thing now with 3. Whereas 3, not there, not there. So this is a 3-6. And so if that's a 3-6, I have a much easier way to prove that this is not a 3-6. So this now can't be 5-6 because there's a 5 and a 6 in the column. So it's not 5-6. It could maybe be 3-8 or 2-9 or 4-7. I forgot about 4-7. Okay, so it can be lots of things. I did that right. 4-7 or 3-8 or 2-9. Yep. All right. Can't be 3-8. Let's see if this was 3. Well, certainly that's not the 3. That's not the 3 either. I see why it can't be 3-8 because I did not Sudoku goodly. So also this can't be 9, so that can't be 2. Good point, good point. Yeah, it's possible I should start coloring 7 9s. Maybe that's the message of this 7 9 pair, because it lets me color. So just in honor of 2-10th, let's try and see if we can color any of the 7 9s at all. That's purple. Oh, hey, Franco. Where are 1 and 7 in box 8? Excellent, right. This row has a 1 and a 7 in it already. So 1 and 7 aren't here, they're not here, 1 and 7 are here. Great spot to Gary in there. There's a 1 7, so that's not a 7. So that's not a 4. So that's another 7 9. But is it a yellow 7 9 or a purple 7 9? It's hard to know. I actually know, because yellow and purple in this column are gone. And so where does yellow go here? Yellow can only go here in this box by Sudoku. Let's see. What about purple in this box? Oh, purple in this box annoyingly can go in 2 places, can't it? No, it can't go there. Right, we have a 7 9 pair and a 7 9 pair, and purple can't go there, so purple's there. So 7 9 pair, or 7 9 there. So now where does purple go in this box? Who knows? One of those 2 places. Never mind. Let's see. Should we fill in row 7? Yeah, we probably can fill in what these digits are. I'm going to bet. So we've got a 1, 2, 3. We need a 4, 5. We've got a 6 and a 7. We need an 8. And we've got a 9. So these are from 4, 5, 8. So these are just a pair now. These are a 2, 3, 4, 5, and a 6. For whatever that is worth. That gets me a 2, 6 pair in this column. Intriguing. So 2 and 6 in this row are now only in 3 places? Are there any of these cells that can't be a 2, 6 for some reason? Oh yeah, we've also got a 2, 6 pair in column 3. Sadly, that doesn't do anything immediately that I'm able to see. Let's see. 1 in column 5 suggests Admiral. Right. No 1 up there. Oh, by the way, this isn't a 5 either, while we're doing things that aren't things. But the 1 in this box is already gone. The 1 in this box is gone, so this is a 1. Very nice. So that means I get to fill in these digits. 2, 3, we've got a 4, we need a 5, we've got a 6, and a 7, we need an 8. So these are from 2, 3, 7, 8. This one I know is not a 2. This one I know is not a 2. This one I know is not a 2. I know they're not 2s because of the 2, 6 pairs. And so now I know where the 2 is in this row, because now this is the only cell that can be a 2. And so we get the payoff of disambiguating the coloring. 9, 7, 9, 7. That 7 makes a 6 and a 1. That makes a 3 and a 4. Makes that an 8 and a 4 and a 6. Makes that a 2 and a 6 and a 2. Let's see. That's a 5. We're going to see how many things I fail to remember to color. This isn't a 5. This one's not an 8. That one, who knows? That 4 looks over there and makes that makes that an 8 and that a 4. So this row needs a 1, a 2, and a 3. And it's got a 4, 5. It needs a 6. It's got a 7, 8, and 9. So this isn't 1 or 2. Or 3. This is just a naked single 6 once you examine the options properly. So these aren't 6. That one's not 1. That one's not 3. That one's not 2. I put an 8 somewhere, didn't I? Yeah, I put an 8 there. This isn't 2, 7 anymore because there's a 2 in the box. This isn't 4 anymore because there's a 4 in the column. So that's an 8 and a 1 now. So that's a 7 and a 1. I know I placed something that I saw eliminated something. I think it was this 5 that places a 5 here. So this cell is now a write-in. 4, 5, 6, 7, 8. This cell is an 8. So now there's an 8 here by Sudoku. So I can find the sum of these two cells. Let's see. These sum to 18. Plus 19 is 37. And so these two cells sum to 8. And they're not 4, 4 or 2, 6. So they are either 3, 5, which they're not, or they're 1, 7, which is what they have to be. They're not 3, 5 because this cell can be neither 3 nor 5. So these are 1, 7. And that's resolved somehow. That 7 looks up and makes that a 1 and that a 7. Makes that a 1 and that a 7. Makes this a 3 or a 9. Let's see. So it's one of 2 places over there. Let's see. I was going to say, oh, this can't be 8, but it was never going to be 8. I should fill in these. These are 4, 5, 6, 9. Well, at least those aren't 6. So one of these two is 3, but who knows which one. 8 in column 5 is a smart point from Martin. 8 is in this box already, so 8 in this column goes here with a 4 there. This is just a pair, so this is going to be a write-in after I do my homework and write this in. This is a 2 and a 4. And so this is now a naked something. It's not 1, 2, 3, 4, 5. It looks like it's a 6 to me. So there's definitely a 6 over in this 20 sum for whatever that is worth. In fact, it's in one of... Oh, in fact, it's exactly there. I know where the 6 is. By the magic of Sudoku. By our powers combined. Do I have all the 6s placed? I do not, but I probably approximately should. Yeah. One of these is a 6. I should have noticed at the time. And so that's a 3 and a 6. So that means I get no more help on the 6s. So we got a 2, or we need a 2, a 3, we've got a 4, we need a 5, we need a 6, 7, 8, we need a 9. These aren't 3. These aren't 9. Hopefully those numbers really do add up to 19. Let's see. Weirdly, this cell can't be a 3. Because if this cell is a 3, it makes that a 1 and a 2, which makes that have no value. Is there some easier way to see that? That is some basic thing that I am missing? I am going to use it, but it's weird to me. All right. It's just asking where 3 goes in row 4. Got it. Because 3 in row 4 has to go in one of these two, so that can't be a 3. That is the easier way to see it. I was hoping it was going to be one of those weird Sudoku things, but it was just it was a fairly innocuous looking Sudoku thing. Okay, so let's pencil mark this cell. So we've got 1, 2. We need a 3 and a 4 and a 5. We've got 6, 7, 8, and we need a 9. Well, this isn't a 4 or a 9, so it's a 3 or a 5. So that's a 3, 5 pair, meaning those aren't 5, meaning those are a 4, 9 pair, meaning these aren't 4 or 9, meaning they're a 5, 6 pair. Which means that... okay, which means I'm going to pencil mark this column. 1, 2, 3, 4, 5, 6, 7, 8, 9. So from 1 through 5, that one is not a 1. That one's not a 1. It's also not a 5, owing to the 5, 6 pair. That one's not a 1 either. So only one of them can be a 1, which is that one. And so that makes that a 3, a 2, and a 1. Making life start to go a little bit better. So now we've got 1, 2, 3, 4. We need a 5. We've got a 6 and a 7, and then we need an 8 and a 9. I don't think we get any help on that right away. This isn't a 2 anymore because there's already a 2 in the box. One of these is a 2. These are a pair. Let's fill in that pair. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are a 2, 6 pair. Turned out that doesn't actually do anything. Let's see. I probably should start to think about this killer cage up here. Let's see. So this is 20 and 30. If this is a 9, that would be 39, and I would need these to add to 6. Without using a 2, they would have to be a 1 and a 5. That seems possible as long as it goes in that order. Otherwise, this is 33, in which case I need these to add to 12, which also seems plausible. They could be 5 and 7 as long as it's a 5 there and a 7 there, I think. How about this? This 3 sees this cell that's marked 2 or 3, so that's a 2. That 2 sees back over there that that's a 9 and a 2. That 9 sees the 4 and the 9. Smart point. There's a 1 placed here. That is probably the thing I was supposed to see. This cell is a 1 just by Sudoku. I was probably getting there, we're going to say, because I can fill in these 2 cells now. I think I was about to get there, but yeah, that's a 1. So that's going to give me this box once I get back to it. 2, 3, 4, 5, 6. Yeah, so this is a 7, 8 pair. And so this row is, let's see, we've got 1, 2, we need a 3, we need a 4, we need a 5, we've got a 6, 7, 8, 9. So these are 3, 4, 5. That one's not a 4, that one's not a 3. All right, but now let's do this again. If this is a 3, then the total sum of these cells is 31, 34, and I would need this cell to be an 11. So that's not going to work. So instead, that's a 9, a 3, and a 9. So that's the 9 over there. So now I do my math again because I've already forgotten. So these sum to 40, if I understand correctly how math works. So that's going to be a 5 and a 3, and a 2 and a 4 and a 2 and a 5 and a 3 and a 6 and a 2 and a 5 and a 6. That 5 looks down and gives me an 8 and a 7 and a 9. Let's see, that 3 looks down and gives me a 5 and an 8. And so this is not a 5 or a 4, so it's a 3. These two cells, I should probably know what they are. 1, 2, 3, 4, 5, 6. This is a 7. 1, 2, 3. This is a 4. The 8 and the 9, look at that, making that a 5. So that's a 3 and a 5, an 8 and a 3. And we have to work out meticulously what the bet cell is. It seems like the bet cell is going to be a 4. Woohoo! We did it. Yes, that was very fun. I enjoyed that a lot, and it was very quick. Somehow much faster than Zeta's Nightmare. Alrighty, I'm gonna dig up. So I'm gonna dig up another puzzle. It will not be a super long one, but I'll dig up and do one more for you. So I'll be. Oh, there was intended to be tricky logic with the 20 clue, but I just ignored it for the entire solve until until there was a one place that did it. Rebel. Alrighty, I'll be right back. It was an excellent puzzle. I really enjoyed that. I particularly liked the use of coloring. I thought that was that was clever. A 1-star ambiguity puzzle. I do love ambiguity puzzles. It is an easy thing to sell me on. I think ambiguity puzzles are one of the coolest ways to like make a vanilla puzzle. Or I mean, it's like ambiguity is like half a step above vanilla, but it really like pushes you to think about all the usual like vanilla tricks in an interesting way. Anyway, be right back. Alrighty, welcome back. We're going to finish off with a Playmaker puzzle, but I am being told my noise filter has gotten off, so I'm going to reconfigure it, so 1 second. There we go. Hopefully that makes my voice sound a little bit better. Alrighty. Playmaker has a lengthy series of arrow puzzles that we have done many of on this stream, and this will not be the last of the ones we do, I'm sure. And this one is a double arrow puzzle, so I'm doing this because doing this now because we just did a double arrow puzzle earlier, so seems fun to do another double arrow puzzle. I know double arrow is not the most standard constraint, though I think it is a very cool constraint. All right, so we have regular arrows. The digit in the circle is the sum of the digits along the line. And then double arrows, where the sum of the digits along the line is the sum of the two circles at the ends. All right, so I am noticing right away that these digits need to sum to at least 15. And so these digits, in order to make these two circles sum to at least 15 without using a 6, I need to use digits only from 7, 8, 9. Oops, sorry, 7, 8, 9. And this digit... Oh, I don't know anything about that digit. No, never mind. I was gonna fall for the old trick of the bendy arrow that bends into a different box. I do not know where it is. But so these sum to at most, I guess, 17. Yeah, the huge line is very interesting. So the absolute minimum that this can sum to is 12 plus 1, so I'm making these 1, 2, 3, these 1, 2, 3, and this 1. That would be 13, so that would make this already 7, 8, 9. I feel like there's some algebra I could do down here, but I'm, for whatever reason, trying to avoid it for now. 6, 7, 8, 9. These are all at least 3. So what's true in this box is that double the sum of these is equal to the sum of these. So actually, this all sums to triple the sum of these circles, for whatever that's worth. I'm being told if I look closely, I can't actually do the thing I said. Ah, yes, I see why. Right. This can't be 1, 2, 3, because that would make these at minimum 4, 5, which would immediately break this arrow. So, so these are minimum... Is 1, 2, 4 possible? Yes, 1, 2, 4 is possible, because then this could be 3, 5, and 1. So because of the impact on this arrow, these can't be 1, 2, 3, and so this can't be 7. It's only 8 or 9. And so that means that we have to be we only have 1 degree of freedom. So these are at minimum from 1, 2, 3. That's at minimum 1. This is at minimum 1, 2, 4. We have 1 degree of freedom on top of that. So these could also be 4. This could also be 2. And these could also involve a 3 or a 5. Just by virtue of... just by virtue of the fact that we only have 1 degree of freedom. So it's worth noting, I suppose, that these plus this sum to a minimum of 15. The minimum is 7. So these need to sum to 8, is the point. So let me go back to the minimum, just because I think what I'm about to say is clear. Sorry, I think I'm going to say something wrong, but we'll fix it in a second. The minimum here is 7, but the minimum of these two together is 15, because it's a sum of 5 cells. And what that means is that these two cells, because of our 1 degree of freedom, need to sum to at least 7. Which means that this is an 8 or a 9, and this is a 1 or a 2. And so I can now return to the properly pencil marked version of this. Yeah, the shenaniganery going on in box 9. Yeah, there is some interesting stuff. I'm noticing we suddenly have the 6, 7, 8, 9 quad, although it seems like a very uninteresting place to have a 6, 7, 8, 9 quad, because I never wanted any of these cells to be 6, 7, 8, 9 anyway. Like, that wants to be a small digit. Let's see. I guess I could ask... aha! Here's an interesting point. Where does this digit go in box this one? So this digit's going to be purple. Can't go there. It's not those two. It's not those two. But it also can't go here because of the quad. That's what the quad does. This cell is purple. So these are both the same. And now that's going to eat our degree of freedom alive. Because now if these are both 8, that's saying that these sum to 7 and these sum to 7. And now that's 5 cells that only sum to 14. So that has to be a 9. And that is our first pair of digits. Nine dance. Doodlip, boodip, dip, boodip. Nine dance. Boodip, boodip, dip, boop. Ba, 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 ba. Ba, 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 ba. Thank you, Zach. And yes, that's awesome. That's very cool. So these are, one of those is 9. This isn't 9. And so notably, there's a 1 over here. Box, yes. This box now has a 7-8 pair, which means that these are a 1, 2, 3, 4, 5 quintuple. That's the only way I get to 15. So these are a 6-9 pair. 9 in this box is getting awfully restricted. I mean, I'm going to guess it's going to end up going there. But I guess the point is 9 in this box now can't be in either of those cells. So 9 in this box is certainly in one of these cells. So 9 in this box is in one of these two cells. So now where is 9 in this row? 9 in this row can't be here, it can't be there, and it can't... Oh no, it can be on the lines, darn it. 9 can go on the lines, 9 can't go in the circles. I was about to say something silly. As I am sometimes wont to do. Okay, so can I work out where my degree of freedom actually gets used if I look at this carefully? I might be able to. So if I made these 1, 2, 4, then I would be forced to also make these 1, 2, 4. Is the version where this is a 2. I feel like I'm supposed to see how to unwind this nonsense, but I do not yet see it. Is it interesting that row 9, column 7 can't be 9 now? So I guess the thing to note about this is because I have 2 arrows that have the same sum in the same boxes, has to be at least 5. Notably, it can't be 6. And then it could be 7 or 8, but it can't be 9. Why can't 9 be in row 8, column 7? Because that's on an arrow. This digit is the sum of these two, so this can't be a 9. So if this is a 5, then this is a 1, 2, 3, 4 combo. Which doesn't immediately seem to break, as best I can tell. It could, but I don't see it if it does. No problem. I'm always happy when people ask why something they don't see is true, because often the reason is it's just not true. But also I like to be helpful and explain these things. So I'm looking at, funnily enough, the sum of these things. So, by the way, my mental proof that I don't think I can do anything interesting here was that I could do that. And so I don't think I can use the math of this box to increase that. So that's why I'm not squinting at this anymore, and I'm now looking at this column. But I think all that's giving me is that these digits sum to at least 10, which is not maximally refreshing. Do I know for sure there's not a 7 on this arrow? I think I don't even know that there's not a 7 on this arrow. So I think this could be 711. Which is regrettable. See, if this is a 2, now this is 1, 2, 3 exactly. This is 1, 2, 4 exactly. That doesn't speak to me completely. So the sum of these cells is a multiple of 3. That's not speaking to me. I was thinking I could get something about like, and then these sum to a multiple of something, but I don't think I can. This given 7 is fascinating to me. Okay, is there a reason this can't be 171? I would love to have that known. Yeah, there does have to be a 1 in here because this needs a 1 and a 2. So let's see. I can pencil mark this if I do this. There's a 1 and a 2 in here for sure. And there's a 1 in here for sure. So, like... right. That tells me that there's not a 1 on this arrow. That's the point. This can't have a 7 on it. So the 7 in this row is in one of these two cells. One of these two cells is 7. Because I can't put a 1 on here. Because again, the minimum here is 1, 2, 4, and I don't have enough degrees of freedom to take the 1 away. So can I put a 6 on here? No. So these are neither 6 nor 7. So these are from 1, 2, 3, 4, 5, which gives me a that was terrible pencil marking, but that gives me a quintuple in the row. Because as soon as these can't be 7, they can't be 6 either. They're from 1, 2, 3, 4, 5. And so now these cells are all from 6, 7, 8, 9. And this one's not a 7. Actually, none of them are 9. Oops. None of them are 9. Because there's a 9 in the row already. These are from 6, 7, 8. Stream's going well, Malcolm. It's been a lot of fun. Earlier, by request, I did one of my old puzzles, which was fun, and I think not too embarrassing. And then I did a cool 2-10th puzzle and a cool Jay Dyer puzzle that I quite enjoyed. Although I think chat thought I was very, very, very slow at it, but I didn't think it was that slow. But what are you gonna do? Can get rid of 1 pencil marks in box 4. Oh, right. These are not 1. Right, we know these are not 1. Row 9, column 7 can't be 5 anymore, since you can't hide all the high digits from column 9 in the box. Ah, okay. So yeah, so if this is a 5, then these are a 1, 2, 3, 4, 5 collection, and now you have to fit these 2 6 7 8s and this 9 into these 2 cells only in this box. That is a gorgeous spot, Garion. Well done. So in fact, we have a 7 8 pair in this row, and so again, funnily enough, we have our 1 2 3 4 5 hanging out down here. You've set some double arrow puzzles? I haven't seen them. I tend to do most double arrow puzzles, since double arrows are my baby, but yeah, if you've got links to reasonably reviewed and tested double arrow puzzles, I will be happy to take a look at them. So 7 8 in box 4. Ah, good spot, good spot. So this 7 8 pair has to get pushed over to here. And so now this is a 1 2 3 4 5, and it's not a 1 or a 2. So this is a 3 4 or 5. Of course, all of these are from 1 2 3 4 5. I think double arrow is a lot of fun. I might be biased. So here's an interesting point. Only 2 of these cells can be from 1 2 3 4 5. So one of them is at least 6. Because there are already 4 1 2 3 4 5s in here. So one of these is at least 6. The other has to be at most 3. And so this digit has to be at least 7, because one of them has to be at least 6. So this is always a 7 8 9. Yeah, and one of the circles is at least 6. The other one's not, of course. The other circle is at most 3. Sadly, I don't have any at most 3 digits to pair this with other. I have 2 at most 3 digits. Yeah, one of the circles is at least 6. And so that actually does tell us whichever of these circles is at least 6, I don't know which one, tells me that one of these is from 7 8 9 as well. One of these being from 7 8 9 doesn't do much. They could both be from 7 8 9. 6 3 doesn't work. So can't put a 9 on the line. Why couldn't you do... So 6 3, just to be clear, doesn't work. If this is 6 3 9, it breaks that cell. Why doesn't, like, 9 7 2 work? The fact that this can't be 1 7 8 is also interesting. There's several sort of combinations here that are broken. Yeah, I don't know one of these two is 6. All I know is that Yeah, so oh, okay, that's a good point. Okay. So the point is 3 can't go in one of these circles. So one of these circles is a 1 or a 2. I don't have a great way to pencil mark that. But it forms a virtual 1-2 pair with this one. And so these cells aren't 1 or 2. At the very least. And now that places 1 in this box out of nowhere. So now 1 is... I didn't take 2 out of that cell somehow. So now this is the 1 for the box. Right. And now remember that yellow needs to have a 2. That's not a 2. So that's a 2. So that's a 1. So this is not a 1. All kinds of nonsense is happening now. And now this is a 2 for the box. So these aren't 2. None of these are 2. None of those being 2 tells me how this works. Because remember, it was 1, 2, 4 was the minimum. So this is actually 1, 3, 4. There's no 5 in it. And so this is 1, 3, 4. And so if that's 1, 3, 4, this is the 5. And so now 2 plus 5 is 7. So this is a 2. And so one of these is a 1. Now this can't be an 8, because if this was an 8, it would be 1, 7, 8. That's not going to work. So this is a 7 or 9. So this is either 1, 6 or 1, 8 with a 7 or 9. This is a 3 by arithmetic. And this is a 4 by Sudoku. This is a 4 by Sudoku. This is, let's see, this isn't a 1, so that's a 3, 5 pair. So that is a 1 by Sudoku. And so now, where's the 8 in this column? The 8 in this column now has to go here. Where's the 7 in this column? The 7 in the column has to go here. So now, wait, no. I said something dumb about 8s. No. 8 can go in the circles. Sorry, I was hoisted by my own petard. Okay, okay, there's a 7, 8. One of these two cells is a 2, for whatever that is worth. Oh, Garion says 8 can't put, or you can't put 8 in the circles? Right. You can never put 8 in one of these circles, because as soon as one of these is 8, then these others become 9. Beautiful. Okay, right. Very good point, Garion. These are not 8. So that is 7. So that is 8 and 7. So that is 9 and 6. So these 3 cells are 3, 4, 5, 6, 7, 8, 9. Let's see. In order to get a 4 here, I need a 3 over here, but that's okay, because I do have a 3 to give over here. 2, 3, 4, 5, 6, 7, 8, 9. These are from 2, 3, 5. Okay. 5 here is not going to work. If I were to put a 5 here, I would get an 11. If I were to put a 3 here, I would get a 4 and a 9. Okay. If I were to put a 2 here, one of these would be a 3, and that's not possible. So this is a 3, giving me a 4 and a 9. Oops. So these aren't 3. This is an 8. This isn't an 8 anymore. Gorgeous. I very much dig this puzzle. This is my speed. These aren't 2. Let's see. This row I can pencil mark, so I should. 2, 3, 4, 5, 6, 7, 8, 9. These I'm seeing are not 2. That has given me a 3, 4, 5 triple in this box. So these are not from 1, 2, 3, 4, 5. These are from 6, 7, 8, 9. I do know there's a certain segment of the population with whom a lockout lines tutorial would be very, very popular. I don't imagine it'll be one of the first ones I get to, but if I go on long enough, I will not be able to. I will definitely get there. Like, it's certainly in the like top 30 most used constraints. So I will probably get there if this series continues being popular, Max. Okay, so this digit is at least 5. And so this digit's at least 6. It's not an 8. But this digit being at least 5 means this digit's at most 4, but it's not a 1. So this is a 2, 3, or 4. And the only combination that allows this... right. These are from 1, 2, 3, 4, because this is a 6 or a 7. I don't know why I didn't ever notice this, but that means these are from 1, 2, 3, 4, which means that they form a quad with this, which means that these are 5, 6, 7, 8, 9. Of course, these are not 9. That one's not a 7. That one's not an 8. Right. This always has a 2 on it, so this isn't a 2. This is a 3 or a 4, which means that this can only be a 5 or a 6, which means that this is a minimum of 8, but it can't be 8, so it just has to be 9. Gorgeous. So that is a 9, so this is not the 9. Was either 3, 6 or 4, 5. I'm trying to decide if any of that would break this arrow down here. Let's see. How many low cells do I have here? Not enough, I don't think. These are not allowed to be 3 by Sudoku, because there's already a 3 over there. That's a good point. So, funnily enough, one of these 2 cells is a 3, so there's a 3 down here. I guess I'll pencil mark it. It's a very good point. I'm uncertain what to do with it just yet. I'm very proud of how the Kropke one went. I think the Kropke one went very well. I feel like arrows actually have so much going on that I fear the arrow one might have come across a bit disjointed, just because there's so much going on with arrows. Like maybe it should have been 2. I don't know, but let's see. There is a 7, 8 up here. So the arrow is 7. But that could be 3. One can't be on the row 9 arrow. I don't see why yet. Oh, if No, if this is a 7. Oh, it's too small. Right. These numbers are now so constrained that if I use a 1, I don't get big enough. That's a very clever point. So these are at least 1. If this is a 7, then I need to put a 3 here. Sorry. No, wait. If this is a 6, then I put a 1 here and a 6 here. I put a 3 here and a 1-2 pair here. Well, I very much am happy to hear that the Sudoku tutorials are doing their intended job. I've heard from a lot of people that they like the stream, but they have a hard time following stuff. So I'm hoping that they do a good job of sort of helping people get more involved in the stream. Virtual 5 in box 5 looks right. Right. This one of these two cells has to be a 5, so neither of these can be a 5. Those are only from 2, 3, 4. So there has to... No, I guess there could be a 1 on this, couldn't there? Could there be a 1? Does this cell have to be a 1? Maybe that's a 1. I'm just noticing that I have all my low digits. Sort of like one of them is here. It's like, for example, it's no longer possible that this is a 7 with a 2, 5. Sorry, no longer possible that this is 7 with a 3, 4. I guess that was not possible as soon as that happened. If this cell isn't a 1, then that has to be a 1. See, the 2 in this box is shoved over down into these 3 cells. I don't think that tells me anything. I know there is a 2 in this row somewhere. Well, this can't be the 4 anymore. Because if this is a 4, then this goes 3, 4, 1, and now these cells can only be 2. So this is the 9, and the 4, and that's the 6, and that's the 1. So that's something. Yes, and that 4 makes that a 3 and a 6, which makes that a 7. Makes this not a 3. That's not a 4 either, while we're at it. That's not a 7. That's not a 7. That's not a 6 either. How can this possibly have done so little? One of these is a 6. So one of these is a 6. So this isn't a 6 for what it's worth. Or a 7, actually. This is an 8 now. So that's a 6 and a 7. Okay. We're getting somewhere, I think. Maybe, possibly. So yeah, one of those is a 6. There's a 7 exactly here by Sudoku. These aren't 7 or 6. They're an 8, 9 pair. One of these is a 7, and it's that one. And then this is a 5. That's a 5. Yep. So this can't be a 5 anymore. This just can't be 8 at all. That's amazing. If this is 8, it can't be 1, 7, because there's a 1, 7 in the row. It can't be 2, 6, and it can't be 3, 5. So this can only be 7. which is just amazing. So that's an 8, and that's a 7. Malcolm saw that exactly as I was about to trying to figure out what the words were to say that. So this has to be 2-5, because it can't be 3-4, because that would be too many 3-4s. Oh, well, yeah, it can't be 3-4, and it can't be 1-6. So it is 2-5. I don't even have to say a complicated reason. It just is 2-5. So that's a 3. That's a 5. So this is not a 2. That's not a 5. And so once this is 3 or 4, that's 3 or 4. This being 3 or 4 makes this an 8 or a 9. As we work through this, that is now a 4 and a 1. And a 3, which makes that a 4 and a 3, which makes that an 8 and a 9. So that's a 2. That's not a very good 2. It's not my best 2. So there's a 2 and a 4 in the column, makes that a 1, a 2, and a 4. 2 makes that a 5 and a 2. 5 looks back over, says that's not a 5. That 8 looks up and says that's a 6, a 5, and an 8. These are a 6 and a something. A 6 and a 1, actually. So they go in that order. These aren't 3, 4. Oh no, did we miss a bet cell again somehow? This keeps happening. This is embarrassing. Yeah, so somehow I think we forgot again. This row needs a 2, which has to go here, which makes that a 5, a 1, and a 2. This is now 5. This row needs a 3 and well, that's a 4. So this row needs a 3 and a something. This is not a 4 or a 5, so that's a 3. And that's a 5, and that tells me that that's the 3. And now if I look at where the 3 is in this box, it's here. This is now a 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see. These two cells, I need a 4, which has to go here, and a 6, which has to go there. And now we're almost done. 1, we've got 2, 3, 4, 5, 6, 7, 8, 9. That one's the 8. That one's not 1 or 8, so it's a 9. So that's an 8 and a 9. That's a 1. 1, 2, 3, 4, 5, 6, 7. That's an 8. 1, 2, 3. That's a 4. 1, 2, 3, 4, 5. That's a 6. There we go. Wow, that's actually a 40-minute solve of a 4-star puzzle on LMD by Playmaker. That's I feel good about that. That's definitely above my my usual performance. But also excellent puzzle. I really enjoyed that. There is a lot of neat double arrow stuff and regular arrow stuff in there. I'm hoping double arrows take on. We'll see. Or catch on. We'll see. And of course, I mostly made double arrows just in mind that I would make them and then I would eventually make this puzzle. But I also just enjoy them. If you are a double arrow fan, my second most recent LMD page is LMD post is a double arrow deconstruction that I am very proud of, called Double Dip. Or if you want, you can go check out Ranks, because solved it on his stream, so you can just watch Ranks solve it instead of solving it yourself, if that's more your jam. I mean, if someone wants to make a double arrow pack, I'm not going to complain. But I set puzzles so slowly, I can't really make a pack. I've been setting about like one puzzle a month, so if I decided to make a pack, no one would see any puzzles from me for a year. At about the rate I have been setting, so... but it's possible someone else will, and who knows. Many people are faster setters than I am. That is one of the laws of the universe. Yeah, I used to do one a week, but then I started streaming, and so my Sudoku time gets divided differently between setting and solving now. So I solve a lot more, which I think is cool. But if I spend 12 hours a week solving, then it's 12 hours a week I don't spend setting. Ranks spends like 40 hours a week streaming, so it doesn't surprise me that Ranks doesn't have much free time. Yeah, this was an amazing puzzle. I really enjoyed this one. Today's puzzle just all around, because we started with this wonderful Jay Dyer puzzle, which I found very very inspiring. And then we got to do a 2-10 puzzle and a Playmaker puzzle. Oh, great. Well, thank you for joining me, everyone. I had a lot of fun tonight. I hope you had a good day/evening. And I will see you again Wednesday. As promised, Wednesday we're starting with a tutorial in Snyder notation. And we're going to do some practice with anti-night and non-consecutive, I believe. And Monday we are doing Tristan and I are together streaming Outer Wilds. There we go. That's the name of the game. I had a hard time remembering the name of the game. We're going to streaming Outer Wilds. I'm going to be crashing spaceships all over the place. So if you want to time travel and crash spaceships with me, be sure you hang out there. If not, I'll see you Wednesday. And I look forward to it. So have a wonderful time, everyone. And I look forward to seeing you all very soon. Bye for now. I did want to, by the way, thank all of you who support us, because it's been very, very wonderful getting all of the support that we've gotten. It's really nice when we get requests like, oh, could you stream Outer Wilds again? I liked that. Or, oh, could you do more of this or that? I really enjoy hearing that people are valuing the stream, and I very much appreciate those of you who contribute on the Patreon or through being YouTube members or whatever. I should especially thank the Turbines, who really help keep the lights on. David Ratner, Michael O'Connor, Nordy, Franco, and Woofer, all of them do amazing work to help us. Oh yes, and the Satisfactory server, yeah. If you want, you can get in. If you're a supporter, you can get in on the Satisfactory server. I was just before the stream started building a supercomputer factory. So if you want to get in on the Satisfactory server and build your own giant mega factory, there is still plenty of worlds that has not yet been exploited. So you can just let us know and we can get you in on that. All right, I think that really is all for now. But thanks for watching, and I look forward to seeing you all real soon.